to bring you up to date. I know you can talk about presentations but I can still these are all the we always go out and say that. I wonder what happened here. Maybe in the conversion? Yeah?
It's missing site. It's after José Souza. That's what happened.
Oh.
Went to the line above.
Ugh, really? How about that? Is that better?
That's perfect.
You want to just tell them? Okay. I'll give one more minute. A few people have to come in, and then I'll get it started. Should we get going? Yeah? How many? Okay, so I'm going to get us started. So welcome to this final afternoon of AMTA tutorial. My name is Lavie. I'm the Vice President of Language Technologies at Unbabel. And you guys are going to be spending the afternoon with us. We have like 3 hours of content to talk about our work on developing a translation quality framework and a suite of technologies. I think a lot of the people here have heard about some components of our technology, particularly pieces of translation technology like Comet, which has become a very well adopted new automated metric for measuring the performance of machine translation models. Some of you might have heard of some of the other things that we develop. we're trying to give you here a comprehensive view and an understanding of how we've basically built an entire ecosystem and framework around translation quality that drives to a large degree the unique types of translation services that we actually commercially deliver to our customers. So before we get started, I want to, you see a lot of names here, these are all people that have contributed to the materials and the work that we've done in around this broad topic. Not all of them are going to be presenting. There's 3 of us here from Unbabel. Craig Stewart, who's a research scientist from Unbabel, Pittsburgh, in the office in Pittsburgh with me, and Jose Souza, who's a senior research scientist in our lab, our research group in Lisbon. Madalena Gonçalves, who is an NLP quality analyst in our group in Lisbon, will also be presenting some parts of our presentation here today, and the other people mentioned there have contributed to the various parts of the framework and the technologies. Quick acknowledgement to our sponsors again. You've heard this all week, but it's really important to acknowledge them. They've been really critical to the success of the conference, so we want to just quickly acknowledge the sponsors, particularly that have sponsored this tutorial. Thank you again. Okay, so I've already basically covered these. This is the subset of us that will be here and presenting today. I've already basically given you a quick introduction about who they are, and they'll introduce themselves when they're presenting their parts. And other contributors, as I mentioned, to this set of technologies and framework that we're going to be talking about extensively today. So I'm going to start basically with a broad overview of what we're going to be covering here, and just a high-level introduction to the different pieces of the puzzle, so to speak, of our translation technology ecosystem and the translation quality ecosystem that we build, and the different parts of the puzzle, how they fit together. So, and before I even go of that, just a little bit of context about what Unbabel does and why we believe actually this is such a crucial piece of the work that we do in developing technology around translation quality. So you've seen this diagram quite a bit before. We've also included in our previous presentations here at AMTA, you know, this dichotomy historically between machine-only, raw MT that is fully automated, that is increasingly getting better and better, as we know, but in most enterprise commercial use cases still lacks the necessary quality for a reliable customer experience, versus the traditional human-driven professional translation process that fundamentally just doesn't scale to the large amounts of content that is necessary in today's world, and it basically is not a feasible approach at scale. And what everybody pretty much here at this conference has talked about to one degree or another is basically, in this world, basically, how to actually optimize the combination of automated translation through machine translation and human translation or human contribution to the generating translations for the quality that a use case requires. And what I want to kind of impress on you today, that detailed and well-founded technology around measuring translation quality, particularly of machine translation, but also of the work that human translations and human translators and human post editors do, is a critical thing to develop basically technology and services that deliver value on this combination of machine translation and human translation. And in fact, what historically we see, and to a larger degree still by a lot of the providers in the space today, are very simple ways of combining these two things. And the technology that we develop, and we're going to talk about and describe in detail to you here today, allows us to do basically things that are way more interesting and sophisticated in that combination of machine translation plus human contributions, whether contributions to the editing of the translation, evaluating the actual quality of any of the outputs that are generated, or interesting routings, basically, of content through the combination of machine translation and contributions from humans. All right, you've seen probably this diagram before if you've heard about Unbabel. This is kind of the pillars of what Unbabel does. Unbabel is fundamentally a commercial, enterprise-oriented translation services and technology company that delivers end-to-end translation solutions for different content types and use cases to large enterprise, multinational, multilingual enterprises. And we're mostly going to focus on what you see there all the way on the left, which is our AI stack. That's basically where our AI technology is developed basically to support the translation journey that happens on our platform. The platform that Unbabel develops basically is the center point where translations are actually executed in real time on behalf of our customers. And our AI technology is the driver behind what's happening on our platform. But all of these other things basically are critical components of the translation experience and the platform on behalf of our enterprise customers. The community is basically where the humans come in, and we have different subsets of our community that do different things. The ones that are probably most prominent or maybe most obvious to what we're talking about here are what we call our editors, which are basically doing post-editing of machine translation. But we have other types of communities, and managing the community along with the technology that we develop here on translation quality to help us manage those communities is actually a very important component of what we do. So in addition to post-editors, we have reviewers that are ensuring at the end of the work of editors for certain types of content that the quality of the generated content meets all of the objective and subjective requirements of our customers. We have annotators that do annotation of translation errors and give us quality information about specific things that are sent for detailed human error annotation. And all of that actually contributes to this ecosystem that we're going to be describing to you here today. This all generates proprietary data, both actual translation data and quality data that then helps feed in virtuous feedback loops to the entire set of technologies and services. And on top of that, here there's a bunch of integrations into IT systems. Different use cases have different integration points that basically make this a seamless experience for enterprise customers. Okay, so Unbabel has been around now for about since 2013, so I guess 9 plus years. Lots of well-known brands and customers. I'm not going to go into details about that. Okay, so whoops. This is just a little bit about the schedule for today. I didn't realize you put an animation around this, but okay. So we have 4 parts. I'm starting basically with I'll be presenting this initial part, which is describing sort of the entire evaluation landscape, the different components. We'll then have a session that focuses primarily on human evaluation and the framework that we've developed and built upon. Human evaluation is the most accurate and detailed way to measure translation quality, both human translation quality and machine translation quality. It's of course slow and time consuming. We're going to go a lot into detail. We'll give you some of the historical background on it. We've particularly adopted a framework that is becoming more and more broadly adopted over the last few years called MQM, multidimensional quality metrics, a variant of that we're going to describe to you here in detail. And that is like the foundation and the pillar for actually annotating translation quality, and we want to give you a sense of why we think that that is the right level of human quality assessment that actually enables a lot of everything else that we do here. We're going to be aligning with a break, afternoon break, so you can get, any coffee and refreshments between 3 and 3:30, aligned with the other the breaks for the other events that are taking place. And then in the second part, we're going to have an important session that focuses on our automated evaluation technology and tooling. Not just Comet. Comet is one of the things that we're going to cover there. We're also going to cover our quality estimation technology, OpenKiwi and Kiwi, and my colleague Jose is going to cover most of that. And then at the very end, I'm going to come back here and put it all together, describe to you how all of those different pieces kind of come together into a truly an ecosystem around our platform that contributes to different combination of all of this together and creates basically an entire framework that basically reinforces itself and gets better over time. We're going to, just to clarify a little bit, we welcome quick clarification questions if there are any during the presentations. We're going to try and leave something like 5 to 10 minutes after each part of the 4 parts for more detailed questions from all of you, including online, and we're going to monitor the questions also that are online so we can try and address those. Okay? All right. So we're going to start basically with this high-level overview of the translation evaluation landscape. What are the most kind of up-to-date methods, perspectives on translation evaluation? What are the current problems? What has been sort of developed, particularly in recent years? We're going to talk then about human evaluation. As I mentioned, we'll give you a little bit of a perspective, a brief history of human evaluation of translation and different methods that have been adopted over the years, and then an overview of current state of human translation evaluation with a focus particularly on MQM. Then we'll talk about automated evaluation, again, a brief history of automated evaluation, current trends, state of the art, on automated metrics and quality estimation, the clear distinction between, or the important distinction between those two things. And finally, translation evaluation as an ecosystem. We'll give you a brief introduction to the quality ecosystem, the way we've put it together and see it here at Unbabel, and its benefits, and an overview of the core pieces of those framework as we've adopted them at Unbabel. Okay, so I'm going to hand it off over to my colleague Craig Stewart, who's going to present this first part. Thank you, Craig.
Thank you very much. As Alon said, my name is Craig Stewart. I'm a research scientist at Unbabel. I've been with Unbabel about 3 years now. I primarily worked on Comet initially, and now I lead the team, the quality technology team, and we deal with a number of different components of this ecosystem that Alon is describing. So I'm going to jump in here and try to speed through some questions about translation quality to give us a foundation for moving forward. And I'm going to start with talking about what is a good translation? How do we decide, what is translation quality from a very basic perspective? We're actually going to switch over to Madalena, my colleague in Lisbon at the moment, who's going to talk about human evaluation, just very briefly give an overview of where we are in terms of human evaluation and the frameworks involved. And then we'll switch back and do a little bit talk a little bit about automated evaluation and the history there. And we'll try and do all of that before 2:15. We'll see how we go. So we're going to start with this question. To start with, I want to throw out some key terms, just because there's 3 key terms here that will be used a lot throughout the entire set of presentations, and it's very important that we all have an understanding of what they mean. If we talk about the source, what we're referring to is the original language text. Okay, so when we talk about the source text, we mean whatever text was presented before translation. Then there's something called the hypothesis. This is sometimes generally called the translation or maybe the target, but in the context of machine learning, we talk often about the hypothesis. So if you hear us talking about the hypothesis, it means the translation that was produced. And then there's a third thing here, which is very, very key, especially when we talk about frameworks like Comet, being the reference translation. And the reference is a gold standard of translation. And this is something that's kind of a little bit counterintuitive, but when you're dealing with metrics, you need already an idea of what the translation should look like. And this is the reference translation. I'll give some examples of them all, and we'll address this question of what is a good translation. So hello, how are you today could be a source in English. A possible hypothesis would be hola, ¿cómo estás hoy? In Spanish, for example. And this in particular, if you know any Spanish at all, you can probably tell this looks like a pretty good translation. Am I right? Is this a good translation? Nods. Yes, potentially. But the question is, it depends really. If the answer is actually, it could be a good possible translation. It's only one possible translation, right? And the idea of a good translation is sometimes a little bit subjective depending on the type of content or what the intended purpose is. So here's our reference here. And actually we can see probably if the reference is Buenos días, ¿cómo está usted hoy? Probably the translation, the hypothesis is actually not a good translation because we were looking for formal register in this case. So there we go. That's kind of a very basic level of what is a good translation. And this comes down to two dimensions. And I discussed this a little bit in the business critical errors presentation, but there's objective quality, right? There's the idea that we can measure objectively the linguistic accuracy of the translation. And this comes in a number of different forms, right? Have we replicated the right punctuation structure? Are we using the correct genders? Is the translation grammatically accurate? Those kinds of objective things. And then there's the kind of the subjective element too, right? And these really depend on the use case for the translation. Is this translation on brand? Is it useful to me? And those two things you'll find relate to accuracy and utility. The objective is the accuracy of the translation, and the subjective is how useful or how fit for purpose this translation is. And those two dimensions are pretty important. There is quite some degree of overlap, right? Is that sometimes the grammatical or maybe the register used, it is not just the objective, an objective measure of quality, but also can tell us a bit about whether or not the translation is fit for purpose. So there's some overlap. Let's have a look quickly before I hand you over to Madalena for a few minutes of the challenges of doing this kind of evaluation at any scale. Because obviously to look at a single sentence and say, is this good or not? And give it some measure of quality is pretty easy to do. But when you're in a production environment and with enterprise customers, you need to be doing this very, very quickly. And there's some reasons for that. There's two kind of worlds of evaluation, right? There's the automated evaluation and the human evaluation. Human evaluation is where you literally hand humans some piece of text and ask them to provide a rating of the translation. You ask them, is this translation accurate? Is it fluid? Is it understandable? You can ask them any number of questions to establish from a human perspective, is this translation okay? And then you have a number of different frameworks and methods of doing that. And here are some kind of still used methods of doing that. We have, for example, things like edit distance. This is a nice one. If you have a translator post-edit the translation, how much effort do they have to make the translation good? And that, as a proxy for quality, is a good idea of what the quality of the translation is. There's also something at the bottom here. Direct assessment is a very popular method of assessment, where it's basically a Likert scale, and you ask the translator what they think of the translation and ask them to give a rating to the translation. There's lots of different ways you can do this, and we'll talk about some more sophisticated ones in a while. On the automated side, where you want to do this quickly and you want to use a piece of software to do it, you have a bunch of different options. But generally what happens if you're using an automated metric, if you have the availability of a reference translation, a translation that already exists, you can give it to an automated metric like Comet or Blur is another popular one as well. If you don't have a reference, you can do something called quality estimation, which means you show an AI the source text and the hypothesis, the translation, and ask it to give a guess about how close it thinks the source is to the target. So those are the two kind of high level. I'm actually going to skip this in the interest of time. This is an explanation of very, very basic, like how automated metrics work, but there'll be plenty of time to that in José's presentation. And I'm going to skip that too, and just go to the pros and cons for now, right? So on the automated side of evaluation, it's great because you can do things very, very quickly. If we want to iterate very quickly over different evaluation MT models, MT engines, we can use automated metrics to very quickly have an assessment or get an idea of how we're doing, rather than having to send them to humans. And of course, on the human side, the big pro is that humans, you hope, know what they're doing, especially if you're using professional translators. You can be pretty sure that the evaluation you're getting is fairly reliable, although there's some expected error there as well. The two cons on both sides, of course, automated metrics to this point are still not quite as reliable as humans, especially the older metrics like blur, which is now 20 years old. It's good as a lexical metric for some certain things, but generally it's quite unreliable. And then, of course, on the human side, you can expect humans to take quite a long time to do decent evaluation, especially if you're using some kind of complicated framework and you have a lot of text in a particular domain. So those are the pros and cons. I'm going to try to hand you over now. I'm going to stop sharing here. And then hopefully switch you over to Madalena. Can you?
Yeah. Can you hear me?
Yeah, we can hear you great. Can you be able to share your screen?
I think you,
Let me see if I can figure out how to stop sharing.
Can you see now?
Oh, okay. Yeah, we're good. Go ahead.
Okay, perfect. So hi, everyone. My name is Madalena. I'm a junior NLP quality analyst at Unbabel. I've been here for almost 2 years. I'm really sorry for not being there, but hi from Portugal. So I'm going to talk briefly about the human evaluation overview. So manual colorimetrics provide a quality score and also allow a very fine-grained categorization of translation errors. And the starting point of a systematic quality evaluation was with language service providers, so LSPs. And at the time, there was no tooling and standardized methodology. The evaluations were done on spreadsheets. The final scores were calculated with only the number of errors taken into consideration, and the reviewers would assign weights according to different severities. And the problem with the LSPs in the first initial part was that they use a single reviewer to compute the final scores. And this restricted the understanding of its final results because only that reviewer would have a fully understanding of that. And also, it was also impossible to verify if the final scores were aligned with the client's requirements. And to address these shortcomings, then we had in the 90s the standardization of systematic quality evaluation, where two projects stood out the most. So the first project is the SAE J2450. I'm sorry if I'm butchering the name. This is actually the first time I'm saying this out loud and not writing it on a paper, so I'm sorry. So this project was developed by SAE International, where they had a simple score card style for automotive documentation, which featured six error types and 2 severity levels. And then we have the LISA QA model, which was developed by Localization Industry Standards Association, LISA for short. And this was first released as a spreadsheet and then later on as a standalone software. And in contrast to the first project, this one was more specific, where it featured 18 or 21 categories. Some of them were only concerned localization issues to East Asian languages, and it also featured 3 severity levels. So one of the things, although they wanted to promote transparency, they also had its own shortcomings. For example, there was low inter-annotator agreement, where there would be disagreement on error severities, on the error severity and on the errors themselves. And also the standardization of issue types did not merge well with the specific requirements. And as a result of these restrictions, we had different consequences for both projects. So LISA QA model was constantly altered due to adaptation strategies. And then in order to address its shortcomings in the late 2000s, they created a new project, which was Globalization Metrics Exchange Quality, GMXQ. And but unfortunately, due to LISA's shutdown in 2011, this project was no longer carried out. As for the other project, the consequences that they had was they had to acknowledge its own restrictions on only automotive service manuals. Then in the 2000s, we had translation quality assessment, and two groups stood out the most. So we have Translation Automation User Society, TAUS, with its dynamic quality framework, DQF. And then we have the QT Launchpad, which was an EU-funded project with multidimensional quality metrics, MQM, as I'm sure all of you here know about. So the TAUS DQF system addressed several approaches, and some of those approaches were aimed specifically at MT, such as measuring the post-editor productivity, the adequacy and fluency evaluation, the readability, crowdsource evaluation, and so many others. And one of the things that made TAUS stand out from the other projects was that they had done thorough research for their best practices in quality evaluation, where they actually reached out to LSPs and also to their clients. And with that, they created a simple typology focused on the needs of its localization-oriented members. And like the Lisa QA model, its first release was on Excel format with instructions on error counts. And they also in DQF, they had 4 severity levels available. As for MQM, so MQM is a flexible quality assessment framework, which allows the customization by its users. And MQM tried to address the previous shortcomings in quality assessment. And they also adopted some of the ideas developed in the GMXQ project. And the main focus of MQM is to have an objective quality assessment in a short amount of time as much as possible. That's one of the reasons why MQM is still used as a reference in the translation industry. Another asset of MQM is also its own adaptability to several purposes. So we could use MQM for several languages, language pairs, contexts, and contents. So you could either use MQM for a commercially produced translation or for academic translations. But such as all the other metrics, MQM also has its own restrictions. So by being high customizable for its users, this can also lead to a high number of issue types in a typology. And usually the higher the number of issue types, then the lower it's the inter-annotator agreement. Also, the annotation guidelines have specific musts. So they must be very well established, clear, and also with very little ambiguity for the annotators. And also the annotation methodology in itself can be repetitive, time-consuming, which then lead to high cognitive load and also poor annotation quality. So other types of human evaluation, we have direct assessment, which has been used throughout for the evaluation of an MT output, where we have human evaluators ranking an MT output in a binary evaluation. So the MT output is either good or bad. And they also rank the adequacy of the translation in a scale of from 0 to 100. And such as the others, it also has its own restrictions. So direct assessment, we have the discretization of judges' assessments into a fixed number of categories, which then leads to inconsistency in human judgments and then to poor inter-annotator agreement levels. Direct assessment is also non-actionable due to the lack of standardized error typology, which doesn't have enough fine-grained information on the types of errors found in the MT output. So why standardized human evaluation important? With this, we can have a non-ambiguous methodology where we have training, guidelines, and decision trees. We can also have a comprehensive typology, and if this typology is not too fine-grained, then all of these factors can lead to a higher inter-annotator agreement. And contrasting with how it started, now we have better tooling. We have specialized annotation tools to aid the annotators during the annotation process. And with high quality annotations, this can also lead to better machines. And two examples of that are Comet, which is trained on human evaluation outputs, and the QE system Adam Babel, which is trained on in-house MQM annotations. So what are the latest efforts on improving human evaluation based on MQM? So in 2020, there was work on an improved version of the 2014 MQM framework by Lommel and his research group. In 2021, Google launched their own version of MQM. And this year, we created the Unbabble Quality Framework, which will be later discussed in further detail. And this is just a brief summary of the history between Unbabble and MQM. So we were an early adopter of MQM in 2016. Then we adapted the core MQM framework to the Unbabble use case, which was customer support interaction until 2018. And now with the acquisition of Lingo24, we have this new quality framework with the newer MQM compliant methodology. And yes, that's all for me. You can go now.
Okay, if we can switch back to, okay, let me just switch ahead. Okay, so I'm going to continue with the overview of the automated evaluation methodologies. Again, giving you a little bit of a historical perspective and some of the important questions and issues that we're trying to address with our more recent work, metrics like COMET. So the importance again of automated metrics for MT evaluation, machine translation moves very, very fast. As you know, now with neural technology, there's also a lot of commercial activity, lots of developments and testing. And when you're doing this type of development, you cannot basically slow yourself down and be dependent solely on human evaluation. And so the metrics that we use when we develop machine translation systems, particularly both in research, but even more so in commercial settings, are really critical for the progress of the field and just the quality of the translation services and technology that we deliver to our customers. So evaluation metrics really shape the direction of MT research. We use them to compare experiments, to decide what gets published, to identify weaknesses and determine what to work on, and to decide what model we want to deploy in production if you're a commercial provider of machine translation. So they are really, really important. And in fact, you know, there have been, papers even shown that, like focusing on one metric like blue has in some senses maybe, guided research to ignore certain things or focus on things that weren't necessarily optimal. But metrics are, as we've seen, machine translation evaluation is very challenging. So developing, a truly high-performing MT evaluation metric has been very challenging, primarily for the reasons that are kind of specified here. One human reference is just one valid, correct target translation. Human evaluations are the gold standard, costly and time-consuming, and they're also by themselves not always consistent and reliable. So I think this has become even more challenging in the neural era, where translations are overall very good, and we're going to try and tell you a little bit about that and to what extent our newer metrics such as COMET are much better on this. So just a high-level view of what we would like to have from a perfect machine translation automated MT evaluation metric or quality estimation system. Primarily and first and foremost, we want high levels of correlation with quantified human notions of translation quality. We want agreement with all those human evaluations and annotations that we have. We want a metric that's sensitive to small differences in machine translation quality between systems and between versions of the system, so that when we retrain a system and we run the metric, we can actually be sensitive to see if the MT model actually got better and on what things it got better. We want it to be consistent, so the same MT system on similar text should produce similar scores. We want it to be reliable, so MT system that scores similarly can be trusted to perform similarly in production. We want a general metric that's applicable to a wide range of languages, domains, and scenarios, different types of content. A general one that's applicable to a wide range of languages. Then lastly, a non-gameable metric, so it's not susceptible to manipulation and cheating, particularly in objective types of evaluation scenarios. And lastly, ideally fast and lightweight, so it's easy to run and everyone can easily just install it and run it and get reliable results. Of course, it's almost impossible, and we're not quite there yet on satisfying all of these things jointly. But we've made a lot of progress over the recent years, particularly around high levels of correlation with human judgment with high-performing systems, which the neural systems, a lot of them are today. So here's a very high-level timeline of different metrics that have been around. This field of MT automated metric evaluation sort of started around 2000, when these things actually became practical to run on modern computers, and data was around to actually start like measuring correlation with human judgments and things of that nature. Everyone knows, of course, about BLE, which has been sort of a very dominant metric over the last 22 years by now. I'm well known for leading a group that developed Meteor. That's also been a fairly well established and broadly used metric. Those are generally considered lexical metrics. Another well-known one is translation edit rate, or TER. We went through a period where there were other metrics that extended these lexical metrics around the 2010 timeframe. NIST here in the US started doing shared tasks on assessing automated metrics around that timeframe. And then later on, lexical metrics such as CHRF and EC came around. And then on the QE side, throughout the 2010s and 2015, we started to get systems such as Quest and Quest++. And then from 2015 onwards, some neural systems started to also enter the picture. Today, there's quite a lot of different metrics around neural technology, both for metrics, again, where you have references, and for the QE scenario, where what we call a reference-less scenario, where you only have a source and a translation and need to generate a quality estimation based on that information only. I think the biggest change that you'll hear about more in detail is the introduction over the last couple of years of large pre-trained language models. And a lot of the state-of-the-art metrics, not just Comet, including our QE technology, are founded or based on a foundation of learning on top of embedding representations of meaning that come from these large pre-trained language models. All right, so just a quick overview of the challenges with automated evaluation. The number one challenge is to get high levels of correlation with, again, quantified measures of human judgment. And in general, particularly with neural models of MT these days, lexical traditional quote-unquote metrics such as BLE and Meteor have not sufficiently correlated with human judgments, and those are the main issue with those metrics. And that has large consequences. So modeling decisions then are poorly informed and often don't align with human assessment. The cost of verifying and rectifying, errors in the model becomes high, and the human assessment is then we're left with human assessment which is not scalable. And this has bad consequences and limitations on all of the developers of machine translation technology. The other thing that kind of as a consequence of this is of the lack of sensitivity, particularly of the traditional metrics, is a challenge in inability to differentiate between high-performing systems. So nowadays, we have many very high-performing neural systems, particularly if you're adapting those to specific enterprises. The changes that happen in the translation are fairly minimal, and you need a metric that actually is going to be sensitive to those changes and tell you, in fact, if the new model is correcting the errors that the old model was doing. And the new metrics are fundamentally much better at doing that. And we'll hope that you'll be able to understand why. So again, we were very fortunate over the last few years that the foundation of these foundation models, these large pre-trained language models came around and provided us actually with a framework and a representation that turned out to be very, very useful for MT evaluation, perhaps even a little bit earlier than they're proving to be useful for machine translation itself. So these are pre-trained state-of-the-art models that generate highly useful neural representations, embeddings for words and for sentences. The main ones are listed here. There's quite a bunch of other ones. They're primarily developed by the big IT companies, as you well know, Google, Facebook, OpenAI, Microsoft. They all have such large pre-trained language models. They were originally primarily for English, but now all of the big providers have multilingual models, and they are in fact used as the foundation to train state-of-the-art models for many NLP applications these days, including language generation, NER, sentiment analysis, translation, and in particular, they've served us as a foundation for recent breakthroughs in MT evaluation and quality estimation. So what does the metric landscape look like now? We have these n-gram matching metrics such as BLE, Meteor, CHRF. They are good for some use cases and for particularly, I would say, for low performing MT systems and low resource languages. We have embedding-based metrics, kind of foundational embedding-based metrics. And we have basically these learnable metrics that are largely learned on human judgment data that comes on top of these pre-trained models. So metrics such as Comet, BLERT, Ruse, Prism, all attempt to directly optimize the correlation with human judgments. Okay, so a little bit about what comes next. So human evaluation, still carries the burden of subjective rater agreement. Translation is a highly nuanced task, and there's still work to be done to improve both annotation consistency and annotator quality of life. That is the challenge with human evaluation. And then on the automated evaluation, neural metrics are great, but they have known weaknesses. They are costly and energy inefficient to train. They're the current trend of foundation models. The current trend of foundation models only sees them getting bigger and bigger. So as a community, we really need to address the balance between power and efficiency and address some of the weaknesses that are found in these large-scale neural models. Okay, so just key takeaways to wrap up this overview session. One of the things that we wanted you to get away from this, translation quality is both objective and subjective. We are actually trying to actually clearly identify and address both of those aspects. We're trying to develop a framework, including on the human evaluation side and on the metric side, that can measure linguistic quality as objectively as possible and measure it the same way across different languages, use cases, enterprises, as much as possible, while still addressing the subjective need and the utilities of translation, as Craig has outlined earlier before. We believe that MQM is the front runner for human evaluation. It's flexible enough framework in order to actually be applied uniformly or consistently across all of those different dimensions that I spoke about, while at the same time it's specific enough to identify specific translation errors and categorize them. And it's those kind of characteristics make it very good for increasing accurately ability to automate the process of doing the same process through our automated technology. And then finally, the neural metric revolution, of course. Current state-of-the-art metrics and quality estimation are all neural, based on pre-trained models. And this trend looks very promising and likely to continue, but we have more work to do there. Human evaluation It's primarily about making humans more productive and more consistent in their annotations, and a renewed focus on efficiency and addressing some of the weaknesses of neural models. Okay, so that ends this part. So we're going to just pause here and see if there are any questions from this part. This is really just a high-level overview. You've not heard yet any technical details about Comet or our OpenQE or about even our MQM human annotation process. We're going to talk about those in the follow-up sessions. So let's just see if there's any general questions, but let's keep it brief because we have a lot to cover today. Constantine.
So one, do you have any insights in how, for example, Comet accurate across languages and more specifically like language pairs?
So we've done to some extent, certainly for our internal use inside Unbabel, but also in the context of releasing the open source models, quite an extensive evaluation of correlation with human judgments for various language pairs. And we've actually done sort of an in-depth classification of those levels of accuracy. It's certainly the case that it's more accurate or correlates better with human judgments of MQM and other human judgments for certain language pairs than others. We do have evidence that it does reasonably well even for language pairs in which there was no explicit training data for that language pair. But it doesn't work equally well, I would say, across every single language pair.
Alan, much like you are telling that every MT provider, please open up your confidence scores. It will also super great to have confidence score from the metric itself. See how confident it is.
So we've done some research actually on quantifying the confidence, or basically the uncertainty, actually the term that we use. We have a paper on uncertainty of metrics that was published earlier this year at ACL, I believe. And we will try and incorporate some of that into the metrics that we release. Yeah.
I have a
Calandra.
question. So I noticed on your overview, you left out an idea of quality when the utility of the translation is the goal. So from a method of like downstream tasks of what you can do with the translation versus this whole idea of you want to produce an excellent finished quality, so like a post-edit, but instead of that, like if you want to do extraction or Q&A or some downstream task.
So there are different notions of utility, obviously. The primary way we've been addressing that is through the mechanism that Craig presented in his paper earlier this week here at AMTA, which is business critical errors, where we identify and then focus on specific errors that have the most impact on a particular customer use case or a particular end goal, and put the spotlight, so to speak, on that. So in addition to our objective linguistic quality is measured through MQM and estimated through our automated technology, you can also get, representations of counts of errors, of the most errors that are most meaningful to what you're trying to do.
When you say you're going in to look at the similarity in the large pre-trained models, what are you using there? Like a latent Dirichlet allocation or a latent semantic indexing, like Bayesian, you name it. I mean, it sounds like you're comparing similarity of strings.
No, what we actually do is for any type of human judgment, be it MQM scores that we have, a database of human evaluations or direct assessments. After we train the metric, we actually do look at correlations and do analyses about, the variation on the correlation of the metric with those types of human judgments.
Okay, all right, thanks.
Okay. One more and that's it.
Yes, doesn't seem like there's a line up to me. Alon, do you mind bringing up a slide with the metric landscape? And the question is, where do...
This one, or?
No, the previous one where you have the historical... yeah, so where would the systems by model front and mem source fall here? What's the difference maybe?
They are quality estimation systems. Without going into the specifics of the details, I don't necessarily know exactly how much they're leveraging, neural models or pre-trained models, but they are modern QE type of systems.
The line, right? No, the common Q line.
Yeah, they're on the.
They
yeah.
would be on the
Yeah.
on the last part.
Yep. Yeah. Okay. All right. So.
Can I ask small, sorry. Last one, very last, quick. We can. Ah, okay.
Okay. Can someone?
That's fine. I'll ask you later.
Sorry. Oh, if you can unmute then, Silvio.
Okay, thank you. Just very quick, Alon. So everybody loved your presentation. Oh, sorry, microphone. Better now?
Yeah.
Okay, so everybody loved the business critical errors. You guys won the best paper and everything. In addition to that, there was a presentation from Meta about the XSTS, which
Yes.
says, okay, focus your errors on meaning. And at eBay, we have been done this for 8 years now. So to me, this tells that not all errors are the same, right? The ones that have more impact and meaning errors have more impact. So if you look at those errors, then your annotators might agree more. Is that true?
For the most part, yes. MQM does have severities. We do have critical, major, and minor errors, but those are basically kind of like identified as without specific consideration of a particular use case or utility. We have a classification of the entire MQM typology that you'll hear about in detail in the second part. Into different, so certainly it's not the case that every error is weighed equally, which, some lexical metrics, of course, like edit distance, don't really take that into account, but we absolutely do. Okay, thank you. All right, I think we want to continue to the next part. Okay, so I'm going to hand it over back to you. Just, up to.
Alan, if you can answer a very short question while we're opening.
Yeah, go
When
ahead.
you customize, is it more customization to the content or to the requirements? Content. You mentioned they're customizable. Is it more to customize to specific content or to specific quality requirements?
I think to some extent it's customizable to both, but it kind of depends exactly what you mean by quality, by requirements. We use basically the broad data that we have. Yeah, but let's train the metric more about.
What is there a simple answer? No, there is not. Okay.
Okay. All right, let's kick off the second session. I'm going to do my best at this. This was a presentation prepared by a colleague of mine, Mariana Buquicchio, who's a senior NLP analyst at Unbabel. She unfortunately couldn't be with us today, so I have offered as a stand-in to talk about human evaluation. Human evaluation is not my field. I'm a computer scientist, but I'm going to do my best with the help of Madalena to guide us through what we do in terms of human evaluation at Unbabel. We're going to go in depth. A reminder of the sponsors here, which we've shown before. And we're going to go through, first of all, the Unbabel quality framework. So we're going to try and expose the three core components of what is our quality framework at Unbabel. We're going to look at monolingual text evaluation. This part, Madalena will present us some work that she's been doing on evaluating just monolingual text, which is interesting. And then we'll pull it all together with kind of another stab at this question: what is good quality? So we'll start with this Mariana there. I should highlight her in particular, as she's mostly responsible and has the credit for this presentation. So we have, first of all, the Unbabel quality framework, 3 pillars. So we have, first of all, the MQM typology. And the MQM typology I'll show is compliant with the latest MQM 2.0. And we also have an annotations process, which I'll expose a little bit, and some tooling there that we give to annotators to facilitate human evaluation. And then we have the reporting side as well. So how we talk to customers and expose this quality to customers, the 3 pillars. And we'll start with the first. So I mentioned that the MQM typology that we have is compliant with the most recent version of MQM, down to the degree of the very top level categories proposed by this MQM. We use those to the letter. So it's very minimally adjusted from what's exposed there. And I think actually there's a link hidden behind that. Hopefully the website is working. I think Alan pointed out online that it wasn't working at the moment. We also have a wide range of content types, and this is important. And one of the reasons that we've adapted our typology specifically is to cover the wide range of different content types that we have. Previously, we were servicing mostly customers, the customer service industry, so the content types there were quite limited. But more recently, just in this last year, we acquired Lingo24, and they brought with them a wide range of different stuff, from technical manuals to movie titles to marketing content and that kind of stuff. So a lot of different types of content that we have to cater for. So here's the very, very top level of the typology. And we have 8 categories, which I'll kind of go into a little bit more in depth. We have accuracy, linguistic conventions, which was formerly the fluency category, terminology, style, locale conventions, audience appropriateness, design and markup, and an optional custom category, which is proposed in the latest version of MQM. To go into each of the pillars of the typology, you'll see that we go to varying degrees of granularity, and we have a number of different error types. So what this is, if you're seeing this for the first time, basically, this is a tree of different types of translation error that we believe to be possible and that are worth picking up and pointing out. And I say that last part because one of the reasons that we stick quite heavily to MQM as a core means of evaluating quality is because it's extremely actionable. We can get granular feedback that we can take back to our teams, and they can make specific fixes to MT to allow us to adapt to the errors that are found. I'll go very, very quickly over each of the categories. Accuracy includes issues related to MT and NLP matters. So one of the key things that we've changed here or added here in particular, for example, is something like MT hallucination. This is not a category that's proposed, I think, in MQM 2.0, but we are fond of adding it because it's a means of allowing annotators to point out where MT hallucinations happen. And an MT hallucination, if you're not familiar, is generally where the MT spits out something that is garbage, and this can be like repeated words in a sequence or something like that. So we have that as an addition there as well. We also have linguistic conventions, which I mentioned corresponded basically to fluency, and many of this is the kind of the bread and butter of linguistic quality, right? So things like grammar and spelling and white space and word order. There's a lot of very nice categories there that are used quite often. And then we have terminology. We have term not applied and wrong term for specific customer terminology that is either not used or misused. We also have a category for style, and the category for style we have adjusted to include things like lacks creativity. One of the interesting requirements of some of the content we've acquired with Lingo24 is that there is an element of creativity that's required in the translation. They don't like translation to be word for word or translationese. They like it to be to have a certain nuanced creativity about it. And that's a way that our annotators can spot where that's not happening. Then we have locale conventions, and this basically relates to challenges relating to localization. So things like date and time formats and those kinds of things. And then we have audience appropriateness, which is a very nice one, a nice subjective category relating to things like culture-specific things, things that might sometimes render a translation unsuitable for a particular target audience that might cause offense or something like that. And then a couple of final categories. We have design and markup. We do some web-based content, so we have HTML, and this is a means for us to capture the kind of HTML and markup type errors. And then finally, we have our custom category, And we've chosen to add a source issue as a custom category. And this is a bit of an interesting one because, of course, a source issue is not a translation error. But we include it as a means for our annotators to give us an idea of where something has happened in the source that has affected the translation. What we do, and you'll see in a minute when I talk about severities, is we neutralize this category in terms of the weighting of the MQM score that comes out of the other end. We don't, this doesn't affect the MQM score, it's just a means for the annotators to tell us that something was wrong in the source. So I'll talk now about severities because I started talking about them. We have 4 that we use. And each of these severities in the calculation of an MQM score carries a particular weight, going from the lowest to highest. We have neutral carries a weight of 0. So a neutral category, and actually the only category that we use with neutral severity is that custom source category so that it doesn't affect the score. Then we have minor, major, and critical errors from anywhere from 1 up to 5 and 25 for critical. And basically the minor errors are anything that really kind of doesn't generally affect the adequacy of the translation, but is something that is worth fixing. The major errors then start to where the errors of the translation start to affect the understandability of the segment. And then critical errors are where things start to really, really catastrophically break down the translation and could do things like cause offense or something like that. That would be a critical error. So we apply categories and then on top additionally severities, and then we use that in a combination to provide an MQM score, which gives us an idea of the quality at a document level. So I've talked now about the typology. I'll talk very quickly about our community of linguists. We have a very, very large community of professional linguists, and they are trained translators and linguists. And we have a dedicated team who is responsible for hiring and maintaining this community. They are tested on a regular basis. And there's a very nice relationship with our community where they're regularly given evaluations and feedback and support from this Community Pro team. We also have a set of guidelines which include the typology itself and instructions on how to use our tooling. So we have a central document that annotators can access to figure out what does the typology look like? What are some examples of some of these errors? How do I use or apply particular error types and severities? And now I'll try to give you a little bit of a demo of our annotation tooling. So we have an internal proprietary tool called Unbabble Annotate. This is a fully automated annotation workflow, and it does 2 things. It allows annotators to annotate our content, and it provides facility for our Community Pro team to do administration of the annotator community. And hopefully we'll give it a go. See if I can get this to play. No. Okay, that's all right. Somebody was moving behind me. I thought they were coming to help me. It should be in the Google Drive, but it's asking for access.
On your drive?
Yeah. This is. All right, that's fine. That's all right. Let's skip that part then. That's a shame. I would really like to show you the annotation tool. It's really cool. Yeah, we'll figure it out, and it's just a 4-minute video. So yeah, no, we'll show you. Even if we show it afterwards, it's just a short video to show you the interface.
Craig, do you want me to show in my computer because I can?
Ah, yeah, sure. Do you want to give the?
Yeah.
Yeah. That's
okay.
fine. That's great. Oh, let me stop sharing then. Go ahead.
But I'm not sure if you had the recording with the actual with your voice or
No,
just the
there was
video.
no voice. So if you just play it, we'll just.
Okay.
Even if we'll just.
Let me just. Yeah. Okay. Let me just make sure if it's working. Okay.
And we really don't need to play very much. We can just show a minute or two, and I can skip over it because we're short on time.
Okay. I think it's. Let's hope it works. Okay.
Oh, yes, there we go. Okay, so the annotation tool. Great, so here we have the basic setup of the annotation tool. This is what the annotator sees. This is a customer service chat. So we have these nice little speech bubbles to represent the conversation going down. And you can see here that we have Italian on the right and English on the left. This is the source language and the target language of the hypothesis. What's happening here, although the video seems a little short, but that's all right. What's happening here is the annotator on the right-hand side has these drop-down menus where they can select the specific error category. And down here underneath, you'll see that there are radial buttons relating to those 4 severities that I talked about. So here the annotator has picked up an error. They have chosen minor severities, which comes in yellow. And we have colors that range from yellow to orange to red for the different critical errors. And the annotator is here working through, I think this is Mariana doing this. She's not doing this live, but this was Mariana recording this here. So she's not here in person, but you get to see her do some annotation. But yeah, you can see that the annotator can add errors as they go through and choose the severity and the error type. Fundamentally, on the left-hand side of the screen, you can see a list of the annotations that are being delivered. And you can see that actually, I think when they hover over there, you can see that there's an X, so they could get rid of them if they need to. They can adjust them. They can review what they've done. And then you see they can sort by type and severity at the top there as well. So as they start to list translation errors, they can have a means of organizing them themselves. There's something that I'll show very quickly before we finished. You'll see underneath this, I'm not sure when we get to this in the video, but underneath this bar on the right here, there's something proposed glossary terms. And this allows the annotator to highlight the source, highlight and annotate on the source side, not provide an error per se, but actually gives them a text box in which they can provide a potential glossary term that we could later add to a customer glossary. And then when we get to it, I know, actually, Madalena, if you want to skip ahead, we'll see if Mariana gets to submitting in
I don't think I can do that in the presentation mode.
That's all right, forget it. We'll move on. But down here at the bottom, you see submit or report. When they click there, then they can submit the entire job. There's only one job in this particular annotation batch, but you see that little dot at the top there. They would see their progress through the batch of annotations indicated by those dots becoming colored once they've completed the annotation task. And so when they submit and report down here, that then folds everything together for us, sends it to our database, and then the annotation task is complete. Madalena, do you want to continue seeing as you're sharing?
Maybe
No,
it's better if I stop because of the video.
All right.
Sorry.
Yeah. Absolutely, they can. Yes, of course. Yeah, they have the option of deleting or amending any annotation they do. Yeah. Okay, I'm going to try to go back to sharing.
Then ask another one, or is better afterwards?
Is it a short question? Go ahead. That's fine.
So
we have 20
maybe
minutes.
A short one. So I mean, we deal with similar types of content, colloquial, live chats, stuff like that.
Yeah.
And I can see that for us, the most important types are more related to context appropriateness, like tone of voice, gender, imperative, mood, like for gaming. And I haven't really seen that in your typology like at all. Where does it sit?
We do have tone and aspect and mood in there. They are somewhere in the typology. I don't have the deep knowledge of the typology to tell you where, but I think I'm fairly certain that they're there. We certainly wouldn't neglect things like register, but they're there for sure. All right, so we have something called quality levels. So the next thing that we have done, and I talked about this a little bit in the business critical error presentation, but we have tried as best we can to organize our content type into quality levels. And basically this is equivalent to saying, look, what is the intended purpose for this translation? What is the expected quality of the translation at the output time? And what is a potential pipeline that we could use to build to produce this translation? And so these quality levels relate to these expectations and workflows. Basically, we have 6 quality levels. We tried to organize everything, as I said, by purpose, workflow, expectations, and the intended use. And they basically range from level 0, where the basic gains are that we have instantaneous translation. So this relates to content for chat, for example, where we have synchronous chat and we're trying to produce raw MT. This would be quality level 0, where basically the quality expectation is lower, all the way up to level 5, which is basically our highest accuracy, highest readability on brand translation, and sensitive target audience and things like that, things that we really, really, really need to take care of. This is a really neat way to prioritize and organize content, so that when the first thing we do when we have a customer come in the door with new content is that we can look at these quality levels and make a quick decision about what we think the expectation might be. So even before the customer defines their expectations to us, we can already have an idea of what we might suggest as a particular pipeline, for example. And then we have reporting, customer reporting. So I'm going to do this very, very quickly, but I wanted to show you what is called the customer utility analysis. So we've gone through MQM, we've gone through annotation, we can generate MQM scores. What do we do with those scores? Because we don't want to be showing MQM scores to customers. I mean, of course we could, but if you give a customer an MQM score of 67, what does that mean, and how do you explain to the customer what that means? So what we've tried to do is articulate quality in meaningful terms by using a framework of bucketing translator content into different quality buckets. And so we have 5 different buckets, each of these relating to a different type of quality, and fundamentally relating to the different MQM scores. And what it looks like is this. So at the very, 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 very top level, and this is a bucket that really relates to the very, very highest possible quality of content that we can offer, we've called the best bucket. Then we go down to excellent, good, moderate, and weak. And these are color-coded to kind of try to reasonably represent the quality of the underlying translation in a meaningful way. Excellent is kind of a still higher level of quality, ranging from 94 MQM to 98. And then good is kind of in between, above 80 MQM. Moderate, below target qualities is where we start to need attention to the translation. And of course, poor quality or weak translation at the very, very bottom, which is the kind of areas that really impede understanding and that we really need to critically address as quickly as possible. Then, given this particular framework, we produce these nice donuts per quality level. So this is an example here of the sort of second to lowest level of quality that we offer. We have level 1, and this is what an example donut might look, a custom utility analysis donut might look for level 1. And you can see essentially the distribution of quality scores within the donut, such that at a glance, the customer can get an idea of what the quality of the translation that they're putting through our pipelines looks like. This is an example of a level 5 donut, where hopefully most of the content sits in the premium range. Yes. This is at a job level, so essentially a document level, depending on the content type. Yeah. Then we have the Unbabble portal. And so this is what the customer sees, essentially. This is a page that shows the different pipelines that we offer, the language pairs for a particular customer, the volume, their current volume going through those pipelines, and then critically these donuts, colored donuts representing the quality that they're seeing going through the pipeline. This is an example. This is not a real customer. We made it nice and colorful for you. Hopefully this isn't the quality for English Italian that we're offering, but you'll see there's plenty of color there. But you get the idea that the customer can see at a glance what kind of quality they're getting through our pipelines. So that's reporting. There's also the idea that we can offer particular targets and expectations, right? Is that we try as best we can to define translation quality as fit for purpose, and we can define this by setting particular expectations and adding particular thresholds for translation quality. This is just a means of, at a glance, assessing how we're doing in terms of linguistic quality expectations. And we try to do this using these colored buckets in a similar way with particular thresholds. And Then we come into, this is a bit of deja vu for me, this is business critical errors. And if you didn't attend the presentation on Wednesday, I'll give a very, very quick overview. But the general idea of business critical errors is that we want to try and establish a means of articulating the degree to which we're providing translation that is fit for purpose. And what we've done is we have tried to, and this is a very long definition, but I'll just read the top bit. We've tried to define a subset of that error typology, a subset of errors for a particular content type or customer that represent what we think is the customer expectation, established through conversation with the customer, looking at customer complaint. It's basically a subset of errors that we want to keep track of. And we use this to prioritize issue resolution and error detection. Where we see these business critical errors pop up, those are the errors that we focus on and rectify as quickly as possible. They relate specifically to the quality levels that I showed. So we have different levels. So where I think previously in the previous presentation, I was talking about areas of groups of content. Well, actually what I was talking about was these quality levels, right? Is that for the quality levels, we've grouped our content types into those quality level expectations, and we can apply different groups of BCE, business critical errors, to each of those levels. So now I'm going to switch you back to Madalena, and she's going to tell you about monolingual text evaluation.
Let's go again. Now I'm going to talk about how we adapted the MQM framework to monolingual text evaluation. So we were able to have a monolingual typology which was MQM compliant. So previously, like initially, MQM addressed issue types that could be used for both source and target texts, but this typology goes further from that. So this typology only concerns source and monolingual texts. And in this typology, we covered 3 use cases. So we have customer support agents training, anti-robustness to noisy source, and then finally monolingual proofreading with no access to the source text. In this typology, we also have 4 levels of severities, and we provided annotation guidelines and decision trees. So in this typology, we have 7 parent categories, 35 terminal nodes, and 2 levels of granularity. So these are the 7 categories that we have in this typology. And such as my colleague Craig did, I'm also going to explain further each one of them. So this is how the full typology looks like. And one of the things that we try to do with this typology is to have it align with the unbabble error typology, at least as much as possible, considering their differences and similarities, but it was important to have them align within the company. So linguistic accuracy is used is used when the semantic meaning or conceptualization of an idea is compromised. Then we have the linguistic conventions, which is used for issues that affect the reading and comprehension of the text. Then we have terminology, which is basically the same definition in the unbabble error typology. Then in style, we have specific categories that which are linguistic structures, which are very specific to the content type of chat, such as emoticon, conversational marker, idiomatic, profanity, and abbreviation. Then local conventions and audience appropriateness, it is the same definition as we have in the unbabble error typology. And then finally, we have design and markup, which covers problems related to design aspects of the content. And we only have, the main difference here is that we have some issue types that are related, that only concern the specific use cases of this typology. So the first use case is customer support agents training. So one of the things is that we do is that we annotate customer support sources produced by non-native speakers of English, in this case, the agents. And these usually, the phenomenon that occurs, it's language transfer. where we have the transfer of the grammar rules of their own native language to the English language. And the examples of that can be the addition and omission of prepositions and articles, agreement issues, the use of wrong verb tense, mood, and aspect, and also spelling mistakes. And one of the things that we want to do with this use case is have our LangOps team to train the agents to write better, and then ultimately have agent guides that we will then provide to our clients during the onboarding stage. As for the second use case, so one of the things in customer support content is that we have very noisy source, especially when it is produced by users. And one of the things that we actually wrote a paper about was how the source text errors had an impact on the MT output quality and the strategies that we could have to improve the MT robustness, which we presented this year at EAMT. And with user-generated content, one of its main factors is its own unpredictability, where users can resort to the use of abbreviations, emoticons, idiomatic expressions, also use profanities, and also the variable use of capitalization and punctuation. And with this use case, we want to improve the robustness of our MT systems, which will then benefit the customer support use case and also mitigate the effects of human translation errors. And then finally, so with the final use case, we have the monolingual proofreading for high-end quality content. So this would be content that would come from other companies that our clients had no access to the source text. And the main goal for this use case is to check if the content is accurate and comprehensive, if the linguistic structures, the linguistic standards are aligned for the target language, and also if the readability expectations of the client audience is being met. So this is how our annotation tool looks for for the use cases of this typology. And one of the things, for example, in the case of the source text annotation, we obviously have we have the translation available. But one of the things that we decided to do is that only have the monolingual text presented to the annotators in order to not have the annotation process biased, and also to not interfere with the MQM score. So I think it's back to you, Craig.
Oh, you caught me off guard.
Sorry.
All right, I was reading the chat comments. All right. And look at this, right on time as well. We've got 4 minutes to wrap up. Hold on. Yeah, of course. Do you need her slides back? Do you want to come up to the microphone so she can hear you? That'd be great. Madalena, we have a question for you.
So the section for, we called it in my team input error. You called it the source issues in your. You mentioned that it's not going to be counted in your MQM score calculation, right? How do you?
The source issue in the embeddable error typology or in this typology?
Both.
No,
but in your say for you, so when you calculate your MQM at the end, it's not including any source issue. And what do you do with the source issue? Do you go back to your client and say, we found this source issue, and those are something, do you give recommendations? What do you do?
Yeah, so in the embeddable error typology, the category for source issue is always annotated with neutral. So that would not affect the MQM score of the translation, because that's not the thing that we are concerned in that particular activity. But in this typology, obviously, only a few of the neutral structures that we have with the neutral severity, mainly the ones that are not per se an error in the source text, but they can have an impact on the MT output. And this is something that we actually approached on the paper that we wrote for EAMT. So these kind of neutral structures, they are not an error, but they can have an impact. That's why we annotated them as neutral. And as for a question of, for example, with the source issue annotated with the unbabble error typology, the thing is, by having annotators annotating that category, we can then look out, for example, in the dashboards that we have available in our internal teams, we can then look, okay, this happened frequently, so maybe we should check the actual source, and then we have someone to annotate the source, that source patch, and then if the client is interested, we can actually have an internal analysis with the own client. So it would be like one of the possibilities.
Great. And my second question is, I know you are using MQM version. I was my research of improving our MQM. We based ours on our MQM too. I found that DQF has other typologies, and one of them, and this is in my business case use, is TM match, which I didn't see it in your error rates. But for example, we have clients that they want certain segments to be translated the way they want. It is in their style guide, it's in their TM, and sometimes the MT output is capturing exactly how they want, but sometimes it does not. So we're asking our annotators to, say that it's not in our error categories yet, but I am introducing that because we have these cases. And I didn't see, you have the custom one added, I didn't see the TM impact, if it's matching TM or not.
Now, for those, we have different categories, actually. For example, you mentioned style guides. We have the issue type, which is company style.
Yeah.
So whenever the company style is not being, like the client's requirements are not being met, then the annotator should use that issue type.
Yeah, I'm adding that too, I know, in my new one. So
Thank you so much. Let's try and switch back to the presentation just for one slide. Right, so I showed, first of all, the quality reporting framework. We have tried to adapt the existing or the most recent MQM typology to provide unambiguity is the key, right? We want our translation annotations to be as accurate, as meaningful, and as consistent as possible. And then our annotation results, generally, we use this in a feedback loop, right, to improve our quality. Our annotations are used in a bunch of different places, which is something that Alon will discuss in the very last presentation when we talk more about the ecosystem. And we have tried to unify methodologies to report both on target translation text, but also on source or monolingual text as well, which is what Madalena mentioned. We've talked about what is good translation, and our kind of highest level interpretation of this, which we find useful, is talking about in terms of subjective and objective, right? Translation utility versus the linguistic quality, and those, for us at least, in our use case, are particularly important. And then, of course, we've talked a lot about translations being fit for purpose, and this is really very, very important. Actually, I wanted to point out a comment in the chat that I neglected to mention, and that there was a blog post that I read recently by CSA Research and RLML talking about translation grades, which actually has a number of parallels to our quality levels and relates to assessing the degree to which translations are fit for purpose. And I would heartily recommend that you check out that blog post and the relating work, just because it's a very, very interesting perspective on quality that I think is very important. Okay. Oh, goodness me. No more takeaways. There we go. All right. We'll break now, I believe, for coffee, and we'll be back at 3:30 when we'll have Jose walk us through the automated metrics.
That's
Yeah.
a short question about typology.
Yeah.
So it seems that most of the, well, all of the errors are sort of segment level. Do you have anything related to consistency between the segments and like intra-segment?
There are a couple of error categories, for example, agreement, which will allow annotation across segments. Yes, for sure.
I have a quick question about the example you showed for the human evaluation portal.
Yes.
Or that you have. You said the example was a customer chat. Are you like analyzing the customer chat offline, or because the human translation is usually
yes.
not feasible
Offline.
in customer?
Right. We just provide the bubbles there as a means of kind of articulating that it's a conversation that kind of helps. It's just a visual tool. But all the annotation is done offline. Anything that we do online for chat, for example, is just generally raw MT. This is after the fact, so we can get an assessment of how the MT performed in that situation.
So you're saving the content and then you're kind of analyzing
exactly.
it afterward.
Yeah.
Okay, thank you.
Yes, of course.
The report and the dashboard, was impressive. So the report part,
Yes.
is it automated or you have to do a back,
No,
you have to
it's
increase?
fully automated. Yeah.
You're the best.
That's not true by far. But yeah, sure. Is it this one? Oh gosh. Here, it's probably easier if I just come out and we can scroll through and find it. That's all right. It's the scrolling is reversed, so I have to. This one, sorry. No. If you click on that. Which number are you looking at? At number 31. Oh, sure. Yeah. Here, let me just try to present it again. That's all right. Then I think I know what you're after. This one and this one, right? Great. Thank you so much. Okay. So I don't think. Oh, of course. Got it. You ask them to make you co-host. Yeah.
Because it seems that he tried to help before and it was just a blank screen. Yeah, because it was one of somebody.
What was the video here?
It's in the folder.
QuickTime video file?
Yeah, like for example, VM tutorial or data setup. If you try to open that, I don't know if it was able to share. Okay, here it is. Okay, cool.
Oh, you just had to press play.
Okay, it's running. It's running. Okay. I don't know why it didn't.
Yeah, the other one wanted to went to Google.
Which one was tried before? Screen recording, maybe?
It's this one. Yeah, and this one is draw audio file, so it's
Oh,
not really.
well, there you
it's
go.
not really- yeah. Right, got it.
Yeah,
Yeah, thanks.
So yeah, all these QuickTime ones. I was gonna say, I was wondering what the black video thing was. Yeah, all these
Well,
ones.
this
should
is
play just
also
fine.
there now, you see?
Mhm. Check. Is it muted? Or does it not have sound?
No, no.
Oh, okay.
Yeah, it's just for us to voice over it, so.
Yep.
Pull up on the one file and send it to the QuickTime file.
Yeah. The draw IO one.
Okay, then that's perfect, thank you very much.
Oh, okay. There we go. I was trying to find the shortcut for full screening it. It's just double clicking. Usually there's like, the arrows in the bottom, but there we go. Yeah. Oh, F5.
Yeah, F5. That's from the last one. Was it? This is from the last one.
But you guys all in the whole time, right? Is this someone's?
No, that was from the last presented. I saw them looking back in the room.
Oh, well, hopefully they come back for it. We'll leave it here for now. Okay. I'll put it off.
Glad to hear it. Thank you for your feedback. So we have the range variant of and data, and both of them they should be aligned with the same. We can do that. Again, we have different versions of comments that generate, line blame, line assessment, other types of things. But that's the idea is to have common human standards that are done anchor both comment and unique. Guarantee was a very grain of salt because the extent that this is the challenge of using the operating network. Concept, right? To the extent that your one-time translations are from the same distribution and very similar to the concept, then you need to expect to have the 2D stores that are similar to the stores. But there's a lot of variation. But that's the whole point of 2D, so you can know something is translated to the 40 because of the domain, because then you get you would really benefit from it's not fully combined with
The right guy to ask is it's like what see also that he is slowly
We'll give it about 30 seconds for people to get settled again, and then we'll kick off again. That was for you.
I guess we need the little tones. So I would like to start because we are on a time. Yeah. Yeah. Yeah, it's pretty loud, right? The raining. For those remote, it's raining a lot here. Right? Okay, so I guess I'll start. This is the third session. I hope you're enjoying. This is about automation evaluation, automated evaluation at Ambabo. I'm José Souza. I'm a senior research scientist with the research team, but also working with these marvelous folks here, Alon, Craig. And then I just wanted to say that most of the work that you're going to see here is, of course, a combined effort. And most of it is coming from Ricardo Rey and Dan Stiegt. And I guess we forgot Fabio Kepler here as well, and Craig himself. So, and also Catarina Farinha, which is, yeah, okay. So just remembering the sponsors again. Thank you. And yeah, I guess we have another slide with, yeah, Catarina, and then also work of Mariana and these two gentlemen here, Ricardo Rey, I think he's the main author of Comet, and then Van Stiegt, which is the, I think, responsible for quality estimation nowadays, right? So I'm just the messenger here, so I'll try to convey it well. This is the outline. Oops, there's a typo there. So I'll start just reminding and overviewing what is the Ambabo translation pipeline so I can position exactly what I'm going to talk about here. Then I'll delve into automatic evaluation and give more details about Comet, some shortcomings. I think we have been already discussing in the chat that, you know, these things are not perfect and anything based on machine learning is never going to be perfect. That's something that that is important to remember. And then a very interesting tool that we didn't talk much about this week, but it's MT Telescope. I'm going to give a glimpse about that. Also, in the automatic evaluation session, I'll just show you how you could use Comet, and I'll just show in the command line how you can call Comet on content. Briefly for you to show that it works. Or at least how to do it. Then I will go for the quality estimation part, define it, just talk a bit briefly about quality indicators, which are basically the indicators that were already mentioned in the previous sessions. and some of the models that have been proposed in the past and are currently used. And then some ongoing work that we have touching both quality estimation metrics, so automatic metrics with references, and something that I'm very excited about, which is trying to use both quality estimation and metrics for machine translation in the process of translation. I'll get to that. So the Unbabel translation pipeline, what is this? I think we didn't mention, but the Unbabel translation pipeline is not only machine translation, and it's not only the quality estimation part. We have this kind of linear thing that then it's feedback up to the machine translation point. And the first point of the Unbabel translation pipeline is data anonymization. We didn't talk about anything here because we are concerned about translation quality, but it's important to remember that the data that we use to train our models and that we send to our annotators is anonymized with state-of-the-art anonymization software. Then we have the machine translation step, the quality estimation that we use to decide if it's already good enough or it needs to be edited by the translation community, and then the finished order is delivered to the customer, and part of it is sampled for annotation that then we can reuse to feedback to the machine translation, to the quality estimation, and also for feedback for the translation community. So the previous sessions were about human eval, right? And now I'm going to talk specifically about this box and this box in automatic evaluation, which somehow Comet is there, or MT eval is there. And okay, let's start with automatic evaluation. A bit biased toward Comet, but just reminding the difference between automatic versus human evaluation. I think Alon already talked about that. In automated evaluation, you allow practitioners to iterate quickly over empty models without needing to spend money on human evaluation and then also waiting for it because it's costly. But as I said before, this is based on machine learning models, so it's less reliable, and it's currently not sensitive to granular error. On the other side, you have human annotation that is more reliable and sensitive to nuanced error, but is slow and expensive. So here I'm focusing only on the left part. There are different approaches to automated evaluation. As Alon briefly talked about before, the starting of this research direction was about comparing translation hypotheses to reference translations on a lexical basis. And this means that we check for overlaps of words between a translation hypothesis and a possible reference. As you can see here, Israeli officials are responsible. It's marked as they are kind of the same, right? So this tells me that this translation might be good, but actually you can see that, it doesn't capture the synonyms, right? Things that are semantically related, like safety and security. Another set of approaches are based on embeddings, but still the first iteration of neural-based metrics, and they compare translation hypothesis to a reference translation on a semantic space that was created by these word embeddings. Here you start to have the green parts being recognized. So because these embedding spaces, they allow for relating things like safety and insecurity through this space, so you don't rely only on the surface word and comparing string to string about that. And now, more recently, we have fine-tuned metrics, or machine learning or model-based metrics that are trained on top of big pre-trained language models. And we use that to score translations like humans do. And I think here one important thing that happens is that we can fine-tune the specific model specifically to the kind of metric you care about, be it MQM, be it DQF, be it direct assessments, be it whatever, as long as you have that supervision, that label to train the model. And here you can see that also it's able to recognize that, you know, insecurity and safety, they might be related, but they are not the same thing. You know, they are more precise. The advantage is that they tend to be more precise than embedding similarity. And of course, they capture things that lexicometrics cannot. But still, they have problems. They are not perfect. So I think people mentioned this in the chat that, you know, sometimes you, these metrics, you have a model that was trained on newswire text, but now you need to apply this to pharma, you know, for a BULA, I don't know how to call the prescriptions or something like that, that is very specific and is very different. So you need to somehow adapt these models because they are not magic, right? So this is one shortcoming, and I'm going to go over that soon. Yeah, so I kind of touched that already. So lexicometrics are not able to deal with language variability, so safety and security, they are not captured in that example that I was showing before. The embedding similarity metrics, they depend on the underlying embedding space, which without further fine-tuning end up clustering words that contribute to different severities in translation quality. So again, insecurity and security, for example, they might be similar, but they are antonyms. So these embedding similarity metrics, they basically work like you have a representation for each word, and then you apply a distance or a similarity. But this doesn't mean, so if the words are similar, it might mean that they just have like the same root or the same prefix or the same suffix, and that they are close together, they appear in similar contexts. But this doesn't mean for a translation perspective that they are actually good translations or that they are similar to each other. They are actual adequate translations of each other. So, and this happens because they are not further trained on this specific data and they lack more context. While fine-tuned metrics, they do not seem to learn how to correctly score translation with rare errors, but that can be critical. So sometimes they miss things like named entities or specific terms that are important for a domain or for a content type. And when they are based on large multilingual pre-trained models, they become slower than the other types of metrics. This is a very important thing that I didn't mention. So lexicometrics, you run BLE, you run TR, you run CHRF, you run Meteor, they're super fast, right? So you don't even, in a blink of an eye, they run, but the fine-tuned metrics, they start to be slow and you start to need specialized hardware like GPUs in order to be able to use them. So this is a shortcoming, of course. So just to give an idea about Comet, this is, I think, some template that we use in a lot of presentations. So Comet relies on source hypothesis. This is a fine-tuning metric. I'm not going to go over the BLE and CHRF and Meteor, and I'm not going to go over the embedding similarity metrics. I'm going to jump directly to the fine-tuned metrics because they are considered the state of the art in the public benchmarks and shared tasks of WMT. And they all work pretty similar. So you can imagine BLERT as a BLERT, which is another model that is also state of the art and sometimes better, sometimes worse than Comet. They're pretty much top two systems nowadays. We need to see now in WMT 2022, but in the last 2-3 years, I guess they're pretty similar to each other in terms of performance in quality, in correlation with human judgments. So they, okay, sticking to Comet, it receives the source, the hypothesis translation, and the reference. This is somehow combined and trained and used to train a model, and then you have like quality evaluations that you can use. I'm going to go for the next slide because, yeah, so this uses large pre-trained language models. We have this combination. We somehow combine the representation of the source, the hypothesis, and the reference. And then we use this information to regress on a score. And a score is something that you choose. Usually we have been using direct assessments, and I'm going to talk about that as well, and MQM, but it can be anything. Specifically, Comet uses, recently we have been using a lot the XLAM Roberta large as an encoder, so this means that it has around 500 million parameters. It's a big model, but it's not now anymore among the biggest. Now we have models with, I think, 40 billions of parameters, and it's starting to get out of hand, actually. Anyway, this is a more low-level representation of what Comet is and how is the architecture implemented. So as I said in the previous slide, we have the translation, we have the reference that are both in the same language, right? And then we have the source sentence. And these are passed through to XLAM Roberta and to get a representation for each. And then in the pooling layer, which is this yellow layer that you see, they are combined using these different operations. I think it's not important here to delve into that. Maybe it's too much detail, but just imagine that when we need to train something, we need to somehow represent the sentence of the 3 different inputs and then teach the model somehow that, okay, using this representation, you have this level of quality, which is used by the label, the supervision that you give. And this can be given by different quality indicators that I'm just going to talk in a brief while. After that, after releasing Comet, there were several independent studies in addition to the different shared test competitions in which Comet has been submitted to, that have shown that these metrics achieve the highest correlations with human judgments. I would specifically highlight the to ship or not to ship from Microsoft, in which they observed that Comet was very useful for deciding whether to deploy or not MT models in production. And they have been using, as far as I could understand, in Microsoft for doing this decision, as well as we do internally at Unbabel nowadays. And this is, for us, I think it was a great validation because it is exactly what we use it for. And to see someone using that in a scale that is so big as Microsoft is it validates that it works, right? So, and they do this for several language pairs, and they compare these against different metrics. Not only, they don't use only Comet and say Comet is good. They do it in a scientific, very interesting experimental setting. Okay, now is the part that I hope it's going to work. I just wanted to show you, as I mentioned before, how to use Comet. So first of all, there is I just wanted to mention that there is an online tutorial, online how-to. Maybe Craig could point that in the chat, because I didn't put this in the slide, sorry. But or I can put this later in the chat while I'm not talking, just to be clear. So here, so there is this link here, which is where we have some data that was used for the tutorial in the MT Half Marathon last year. You download this data. It's very small, so it's a few kilobytes. You untar it. Yeah, sorry, this is for terminal, so we are using macOS here, but I'm pretty sure it works in Linux as well. I'm not sure about Windows, but if you have any difficulties, please do write us. We can help if you have any difficulties. And here is just for you to understand a bit of the data. This is some, I think, 1,000 segments for Russian to English from public available data of WMT shared tasks, right? So this is just to show you the data that I'm running on. I do not know Russian, so the point here is just to show how to use this. Is not to evaluate if the quality of the prediction is good, you know, or if the translations here are good. Then I think the first important step here is to set up a virtual environment, or how to install Comet, basically. All you have to do is first create a virtual environment in your machine. You can do that with this command. And all of these will be written in the tutorial that I mentioned that I'll post later. Then you just need to activate this and start to be able to use that environment and install. So yeah, just stop here. This pip install Unbabel Comet, Unbabel-Comet, is all you need to do in order to install Comet. And here specifically, I'm using version 1.0.1, but we have more recent versions that if you just do without the equal 1.0.1, it's going to fetch just the latest version. Then this will run for a while because it uses a lot of other packages that we need in order to that we based our code upon. So yeah, you know, this thing is now going to run for a couple of minutes. It depends on your machine and your operating system. It depends also on your connection with the internet, because PIP is going to fetch these packages from the internet. So you need to be a bit patient, but hopefully it works. So yeah, I just wanted to mention just this pip install that you need to do. Then the first model that I wanted to show is how to run, oops, not this one, is how to run Comet DA based on direct assessments, which is, I think, the default model from 2020 that is currently the default. This might change in the future, but currently this is the one. So you just need to basically write this Comet-score, and then this -s stands for source, so it's where your source sentences are, and then here is, you know, the data that I mentioned before that you could download. Then T for translations. It's an online system, basically. It's one of the big available MT systems on the net. And R stands for reference. And this is just the reference that is provided with your example data. And importantly here, I was running this on my laptop, so I don't have GPUs I can use on my laptop. So here it's going to run on the CPU. I just wanted to show for 1,000 sentences, how does this work? So you see, okay, one thing is going to happen is Comet will automatically download the model from our repositories. In this case, I downloaded, I had it in the cache already. So it takes a while because as we were discussing also in the panel for large pre-trained models, this model is pretty big, it's a few gigabytes. So it's going to take as much time as your internet connection allows, but the good thing is when you try to run Comet again, you don't need to do this anymore like it's showing here, you know? So yeah, now it's just to show you the thing running. This is just some output, basically to understand what's happening. The model is being initialized, and now it started to put things in the RAM memory, and now it's starting to actually perform the predictions of the translation scores. You can see that this is on CPU, right? So if you do this on GPU, it's going to be much faster than this, but it's quite fast. It's reasonably fast for a CPU-based run. And in the end, you have this output that you can redirect to another file, but here is just an example. Then you have like, for segment 70, what's the score, and so on. And then you have down there, you have like a summary, like an average of the whole batch, of the whole test set. Yeah, as you see, it's 52 comet here, which means in this case that the MT did a so-so job. So this is a question that often comes out. Now it's coming to me some things that I didn't think about, but so usually a comet between 50 to 80 is an okayish translation quality. From 70 to 90 is a good translation quality for this model, right? For this WMT20DA model. Above 90, it's very good, and it's quite not differentiable between something that is a 90 and something that is a 92 or a 94. So above 90, you have really good translation quality. Things that are below 50, between 20 and 50, they are bad. They're just bad translations according to this model. And things that are negative are super bad. So you don't want to get near that. So it's something that if you have an empty model that is with negative quality, there is a problem either in the training data. Training data is not aligned. They are not parallel data. It's just throwing out random stuff. So this is more or less the rationale. Okay. How I'm with time? Okay. I want to now show something that I'm going to present later, but it's about, maybe I will present this later. I'll just come back to this later. Let's go back to the presentation. I just wanted to, yeah. Now that I see that it's easy to run and we don't have problems, I can just go back. So, okay. Problems. You can see that I'm saying that Comet is good, but it has Comet and Blur. I'm focusing on Comet because we created it, but we also have some experience with Blur that is in the same lines. Computational performance, like I was saying, right? You saw that it's not super fast, and large pre-trained models have state-of-the-art performance for every task that you can imagine, every problem in NLP that you can imagine, including MT evaluation, but the sizes are achieving astonishing performance. I said before, 43 billion, no, GPT-3, which is not the biggest anymore, it has 175 billion parameters. So imagine we have difficulty even fitting these in the memory of a GPU nowadays, if you're not Amazon, Microsoft, Google, or Facebook, Meta. Here you can see that the model that we are using, they are between these two. So they are much smaller than the biggest models that are available today. Point standing, this is a problem, right? We need lighter and more energy efficient models. And this is something that everybody's talking about. So what we were thinking is, how can we make Comet faster and lighter without losing that much performance? There are different ways. One of them is doing tricks in the inference time to make the inference faster. And this, I'm not going to present this in detail here, but this relates to, caching the representations of the sentences, assuming that they are repeated. So imagine that you are evaluating several models, right? Several MT systems. You have always the same source and always the same reference. The only thing that changes is the hypothesis translation, the translation hypothesis. So you can just cache the representation of the source and the reference, and you compute only the hypothesis each time. This makes a lot of difference in this use case, because you instead of doing 3 forward passes, instead of passing 3 times the 3 inputs through the large pre-trained model, you pass only once the source and the reference, and the hypothesis is repeated for each. So you need to pass through the network every time because they are different. That's it for fast inference. Another thing that you can do in the faster inference is also some tricks, cheap tricks, like sorting the sentences by the length of the source sentence, so that you have smaller sentences in the beginning of the test set, and as they grow, they become bigger. And this helps because these large pre-trained models, they also have a cap on the size, and putting things with similar sizes together just speeds up the computation on the GPU or the CPU. So two things that we approached to make Comet faster at inference time, it's encoder pruning. Encoder pruning is a bit like the Elmo face here. Imagine the Elmo face is not like that, right? So either we remove layers, so you can see that the Elmo face is missing the eyes, for example, or we remove parts of each layer, which means small parts in each layer, we just remove them, making the model smaller. Another thing that we did was trying knowledge distillation, which means having a big model, a very big model that we call the teacher, and use the predictions of that model for training a smaller model called the student. I won't get into much details here, but the outcome is that the student model ends up being smaller, leaner, faster, with a small degradation in performance compared to the teacher. So it's a pretty neat idea. And I'm going now to just present some details about each. So the prune comet in the end was a model after several experimentation, right? We had to experiment with different things, and what ended up helping the most in the end was a model with 80% of the parameters. So you can imagine that it has either like, we used both figures of the Elmo. We removed parts of each layer, and we removed some layers completely. And this means that the XLMR ends up having 20 layers instead of 24. Yeah, we remove 5 layers, 25 then. And the feed-forward hidden size is reduced to 3/4 of it. So we remove 1/4. And we don't have 16 attention heads, we have only 2. Another one is the distilled comet version, which is based on the distilled distillation technique. And this is an ensemble of 5, the teacher is an ensemble of 5 comet models trained with different seeds. To put in more, imagine that these models, they were initialized in different points. So in machine learning, and specifically for neural nets, it makes a difference how you initialize the model. And sometimes it gives you different kind of point of views on the data. And yeah, it's a bit like that, just not to get more technical about it. We had some unlabeled data of 25 million sentence pairs from Opals for a total of 15 language pairs. And the data, the data used for distillation was around 45 million tuples with source, translation, reference, and the score. And this is everything with public data. Is nothing in-house data. And the student is a distilled version of XLMR large, which is this paper by Wang et al. So how does this impact on correlations with human judgments? You can focus on these 2 last lines, and you can see that prune comet that has 80% of parameters achieves 37% of speed improvements at the cost of a few points of correlation. Here we are comparing so you can see in this table that we have several different metrics for different language pairs and on at least 2 different domains, Newswire and TED Talks. And you can see that comparing to the Comet original model, which is in the third line from the last, we have an average of 27 points of correlation. And with prune comet, we lose a bit less than 1 point, but we can have an improvement of 37% in speed and a smaller model, because you can see that the number of parameters goes from 582 to 460. And at the same time, we have the Distill comet model that is even smaller. You know, it has 20% of the parameters, and it's faster, 53% improvement in speed, but we lose 2 points, right, in correlation. And here you can see that in this specific experiment, BLERT was better than Comet, the original BLERT. It had like 2 points above. So you can claim that we are kind of losing 4 points to the state of the art, depending on the approach that you take, but it's much faster for running and using this model. And it's also memory, less memory consuming. And then whether this kind of translation quality prediction is good for you, it will depend on your use case. Again, this was the first experiment that we did in order to have a linear model. There's more to do in this area, and we will be working on this, continue to be working on this. But this was very good, and it was very encouraging to us that we can achieve these results without having 50% cut on prediction, you know. Also, a very nice thing that in EAMT, this was submitted to the EAMT conference. This is like, I think, the sister conference of AMTA, but for Europe. And we had this nice title, Searching for Cometinho. Cometinho is just the diminutive of comet in Portuguese. The little metric that could, that Alon came up with. And this is, well, the team that was representing Ambabo in EAMT. Yeah. So there are more problems. So this was a first stab at trying to alleviate the problem of being slow. But some others remain, as captured by the group of Rico Senrich, the University of Zurich, and Chantal, who was a student. They identified several insensitivities of Comet in the context of minimum base risk decoding. It doesn't matter now what this is, but basically the conclusion is that numbers and named entities were affected by having very weak predictions of translation quality. And this is very worrying, right? Because we want to get these things right. So these are challenges. So challenges that we need to tackle. It doesn't mean that every translation is going to have problems. Every translation that has this kind of tokens is going to be problematic, but you might want to pay attention to this depending on your data, or fine-tune your model specifically with more data containing these things. So we also have some work to try to address this problem that was developed internally in the context of this critical phenomena that happens, because you can imagine that, you know, getting named entities not right and having problems with numbers and other specific errors it can be very damaging. So we had 2 internships, one last year and one this year that is actually finishing, and by these 2 students, Catherine Zhang and Duarte Alves, that are working towards, you know, either enhancing the training data that we use to include more of this critical phenomena and try to guide the model towards having better predictions about this. And I confess I don't remember what Catherine did. It was the tool to stress Comet, basically, making attacks to Comet and you know, poke it so that we could understand what's happening and you know, understand what are the ways that we should approach each problem. So this came even before the paper by Rico and Chantal. And more recently, due to the work of Duarte, we have the introduction of challenge sets in the WMT matrix share task that Ricardo and Alon are organizing, and I guess Craig as well. Yeah. So we have these challenge sets that are going to be used to challenge the metrics. They contain data that are derived from problems like this, and participants could send these challenge sets. Each participant or any person could send this. So for the linguists out here, I saw that I think a lot of people in social media are poking Comet and Blurt. You can, I don't know if there's no more time, but I think probably this is going to continue. You can send specific test sets next year. I hope this is going to continue with the cases that you see that these fine-tuned based models are failing, and send this for the WMT share test so that when the systems are being evaluated, this can be taken into consideration, and we can, as a community, write about it. So I encourage you to do that. And I know that several of you have very interesting use cases and failures about these models. So now, I'll just pause here a brief while. Do you have any questions? No, okay. We have one, okay.
You showed the 1,000 segments that you ran through Comet, right? Do you have business cases where you have 25,000 segments and you have to run it to Comet, and how long it will take to get the report?
It depends on if you're using a GPU, how many GPUs, or if you're using a CPU. I don't know now from the top of my head how much time it's going to take. I don't know if Craig has any ballpark. Okay, okay.
Well, no, I think it would probably take, you know, even a GPU, it would take
You said
an hour.
You said 25K?
Yeah.
But, you know,
example.
Comet is intended to run on representative test sets that are several hundred or several small thousands of segments at a time. And if you actually are trying to assess, you know, larger quality of large volume of content, then it's more appropriate to do that with QE and more part of the workflow.
Yeah, just to paraphrase what Alon said, probably it's better to, because I don't know if people online could hear, you probably either want to segment this into different slices of data, because I doubt that you have one domain only that is 25K. And Comet was intended to be run on smaller portions of memory. But just let me try to give you an estimate. I think, so for 2,000 sentence pairs, more or less, on a GPU with 15 giga, which is a commodity GPU, is one that Amazon probably has much bigger. This takes like, I think, 5 to 10 minutes, 2K. But if you have a V100 or a P100 that I'm sure you have in Amazon, you can fit more data into the memory of the GPU. And these 2,000 are going to be much faster. It's going to be a matter of seconds, right? And if you have 25K, you can throw more GPUs at it, you know, and you can even slice this into different portions and run Comet in parallel on several GPUs and then do the average of everything.
Oh, okay. So for your business case, for your customers, do you run Comet for sample?
Yeah, exactly.
Sample. You do it for sample.
Exactly.
Thank you.
So I'll just go on because I realize it's 4:13. So MT Telescope, it's a tool that we can use for, it's an open source tool that enables fine-grained comparisons between different MT systems. And we did this because translation quality is very difficult to pin down, you know, and standard practice uses tools to assign a quality score, and this score usually determines which translation systems you use. So the scores, they don't tell the full story. Sometimes you want to look at the distribution of these scores when you are comparing two systems. And if you have something like 86.7 and 86.8, well, what's the real difference here? So what Telescope allows is to fully understand the capabilities of a translation system, and it's supposed to be easy to use. It's web-based, and it has an interactive interface that exposes how the different models translate. And this is like what is being shown. You have in the left-hand side the plot of the distribution of the scores in the different systems, and each dot represents a sentence pair with the corresponding scores and the two translation hypotheses. And then another thing that you can have, it's a QA-like or a customer utility analysis-like plot that you see in the right-hand side, in which you can kind of zoom in into these two scores. And you can see that, for example, the left-hand side bar plot, it has a bit more of the red zone. So you probably want to keep and use the right-hand side system because it's slightly better at not making very critical mistakes. And this is derived from the COMET scores. So to sum up is this, I need to go on for the next. Quality estimation. What do we use quality estimation for at Unbabel? I briefly mentioned before, we have quality estimation to decide, okay, red is not good, goes to the translator community to post-edit. Green, good, delivered, right? And we do that without having access to any reference. At that point, we don't have a reference. We don't have a post-edit, right? So what is quality estimation? It's to estimate how good is a translation given only the source, and the hypothesis, right? And the translation hypothesis. And this is typically a black box MT system, but it doesn't need to be. Black box, it means that I do not have access to the machine translation system. We don't have access to the reference translation, and we can do that in different levels of granularity. It can be at word level, sentence level, or document level. The data sets or the types of data that we can use, just to define what I'm talking about here with the terms, source, as we are using, is the text in the original language. Hypothesis or MT hypothesis is the source text in the target language. And the quality assessment is what I was referring to before as quality indicator, but it's either the HTR, which is a score derived from the post edition. So I need to have the post edition at training time in order to get this score, or an MQM score, or a direct assessment score. And if I want to train word level models, and if I want to have for each word a prediction, I have word level tags. And the source and the MT hypothesis are inputs at the inference time. So just briefly, what is the HTR? It's given by running the TR algorithm over the machine translation and the reference, and it's going to identify deletions, replacements, or substitutions between the two, or insertions. And in the end, it's going to summarize this into a number for each segment. And I must say that most of the work when I was doing my PhD, basically, was using this kind of quality estimation data up to 2012, 2015. This was the most common data. Later, after that, it came multi-quality MQM. As you saw, I think it was published in 2014, and started to get traction. And I think I'll just we already know what MQM is. So in the end, the score is given by this formula, but and then each severity has a weight that you can also tailor for your needs. You might want to give more weights to criticals, for example, or to majors. And this is normalized by the sentence length. And this can also be derived for the word level. So imagine that you have a major in blind driving, and this becomes this. So you have everything is okay up to that moment, up to that token blind. And as this is a major, this is tagged as bad. And then I can use this to train a model at word level. Then we also have direct assessments, which I think we already touched as well. They are a bit more subjective than MQM, but they are faster to obtain because you don't need to follow all this typology. But there is subjectivity involved, and this is what was used for a long time in the WMT shared task. So all the publicly available data, the bulk of it, is based on direct assessments. I'm going to just piggyback to the timeline that Alon showed before, and I just wanted you to focus on the southern hemisphere of it, below the solid black line, just to say that, well, these things related to quality estimation started with Quest. Didn't start with Quest. This started actually in 2004 in a JSALT, in a Johns Hopkins summer workshop. And I remember the work of Nicola Weffing and colleagues that put together a lot of features, which are like things derived from speech, because in speech, this is called confidence estimation and has been used a long time, and people trying to do the same thing that we do for quality estimation for MT, but they used to do for speech. But Quest was the first framework that actually put this together in one piece of software that was not that easy to use, and I am one of the authors, so I'm sorry about that. But it was there before everyone needed to develop this ad hoc, basically, and this was the main advantage. Then this is for feature-based QE. Then around 2015, there is the Nero-based QE, and I'm going to talk now about the large pretrain, well, Nero-based and a bit large pretrain QE. And yeah, I think the biggest leap in quality estimation was when this predictor estimator was proposed, and this uses two-stage neural model that is pre-trained with large parallel data without any, so it's basically the green part that you see. And this was done before these large pre-trained models, around 1 year before. And this is by Kim et al., I think is the Post-Tech University in South Korea, if I'm not mistaken. And this two-step approach is composed by a predictor that is trained to predict every token of the target side, given its left and right context. And this was using LSTMs. I don't know if you know what it is. It's just like previous iteration of neural networks before pre-trained models that used to work pretty well for sequential data. And this was trained, and you had the estimator that is based on the representations of the predictor and fine-tuned to predict sentence score and word level text. The thing here is that the green part is first trained, and then the purple violet part is trained after. So they don't share the same training, right? And then with the rise of the transformer, which is a good title for a movie, is the predictor being replaced by a BERT model, by one of these Muppets. And then the estimator is the same thing. The only difference is that the green part is done, instead of using an LSTM or an RNN, is a model like BERT or XLM. Then here is an example of the predictor using BERT or XMR, in which for each word you can have a prediction. I'm just going to be a bit faster because I guess I'm out of time, right? Okay. Then different models that have been used, namely XLM Roberta and InfoXLM. XLM Roberta, XLM is the original model by Meta. InfoXLM is an iteration on that by Microsoft, and they follow this translation language modeling approach. I'm not going to delve into details here, but they're usually XLM specifically and InfoXLM, they are the first ones to be actually fine-tuned on parallel data and start to work pretty well for multilingual models, and specifically for cross-lingual problems in like QE and things that you need to have correspondence between the two sentences in different languages. This is an example of a estimator in which that you have like the source and the translation, and you want a prediction for each position of the translation, and at the same time you can have a sentence score. So nothing new here. The sentence score is given by the feed-forward neural network, and the tag level projections, the word level projections are just linear projections and predictions of that each word. Okay, so all of this is implemented in OpenQE. All of this and more, because I didn't show the Marmot and Quetch, which are other previous models that probably you don't want to use anymore, but they are there in OpenQE. And OpenQE was released in 2019. It got the best demo paper award in ACL back then in Florence. This was the crew representing the company back then. Moving forward, here is an example of how to use QE, which is well, OpenQE. You can load the model, you pass the source and the translation, and then you have the probabilities of being a good translation for each word in the target. This is an example and a visualization of it here. Yeah, and then in this case, it was a good translation, right? And now, more recently, we have the Comet QE dual encoder, which is following the same architecture as Comet, but without the reference. And this started to work. It was, we're just trying to do this to see if this architecture could work well for the QE, and it works. So the sentence embeddings are created using average pooling, and it's pretty much the same thing, but without the reference. And the feed forward is used to predict a quality assessment like MQM or DA. Just to give you, a glimpse of this, if you see the right-hand side in the to ship or not to ship work from Microsoft, the Comet source here is the Comet QE, right? They call it Comet source in the paper. And you can see that it's the second best metric in their experiments following Comet, which was quite interesting to see. Also in the WMT21 metric task results, it was, I think, the fifth best model, and OpenQE fine-tuned with MQM was the sixth. So, so this tells us that, are we seeing that references are not needed for MT evaluation? This is a question, I don't know if I skip this. This is a bit about ongoing work that we have. This is our participation in this year to share task. Okay, I'll briefly go there. Basically, what happened? I'm just going to talk about quality prediction. The main challenges are that our systems had to generalize well to different types of annotations. The data that we had for the share task was a combination of direct assessments, HTR scores, and MQM scores. And you can imagine that all these things that I'm showing to train, you usually need to have only one. And we had to somehow combine this. And they need to generalize for languages for each we have little or no training data. So what we did was to take advantage of the training features from Comet to build models that generalize well and extend Comet with a kind of predictor estimator architecture. Just because this means basically that we now are able to do word level predictions with Comet, right? So before it was not possible, it was only sentence level. And our biggest focus was on multilingual models instead of building one model for each language like we were doing in the past. And well, the public model is multilingual anyway, but in the shared task, we were sometimes building per language per models. And basically, this is the workflow. We pre-train, do a first pre-training or fine-tuning on direct assessments from the matrix task that is available, fine-tune on the specific task data, either direct assessment or MQM, and then do a few shot language pair adaptation with the low resource language pairs that were being evaluated on this year's shared task. And all of this is using the same model, like the multilingual model. And we got some interesting results. You can see here This is an ensemble of 6 different models. And we are much better than the baseline of the task, which is just using XLM Roberta. And we, in average, over all these 8 language pairs, I guess, 9, we get a jump of 7 points. Sorry for rushing over, but I do not have much time. I just wanted to mention what I said in the beginning about some work in which we try to combine or to include and leverage quality estimation and MT evaluation for doing better machine translation. Because what we notice is whatever machine translation you use, Google, Bing, or our internal models, they still suffer from some critical errors or catastrophic errors or major, what we call severe errors that prevent you from understanding the translation sometimes, or that it can cause very important and grave repercussions. So if you change a number, if 1 million becomes 10,000, or when you are writing something for health, and you change a preposition from with to without, which might happen with these models, MT models, this is very bad. So QARTS stands for Quality Aware Machine Translation. And the idea is to use this little thing that has the I don't know how to call that, like a speedometer, which is basically quality estimation, representing quality estimation and Comet. And it's basically a sentence level re-ranker approach in which we are optimizing the re-ranking using Comet QE in the case of re-ranking, or using Comet in the case of using minimum-based risk decoding, which is just basically comparing every translation hypothesis with every other translation hypothesis and getting a consensus. This was used in the past in statistical machine translation, and it was also used for speech transcription. So this is not particularly new. What is new here is using Comet and QE in this process, and it actually works, well, or worked. We even did some MQM evaluation of these, and you can see that for English-Russian, they have a big improvement over the baseline when we combine the trained re-ranker, which is this TRR plus the MBR, and optimize for Comet. We get a jump from 79 to 86 in Russian. In German, not so much, because the German model was much better baseline, so we still get some improvement, and that's it. Yeah. So takeaways, and I'm already out of time. Comet and Cometinho. Comet has been consistently ranked one of the most correlated metrics with human judgments over the last couple of public benchmarks. And here, okay, also, fine-tuned metrics, also blurred. And this is important because this is an important shift in the way we use MT eval. I think there are very strong public statements by different researchers to stop using BLEU for a couple of years now. Maybe we are getting to the point in which you can do that by combining maybe Comet with CHRF, for example, instead of using BLEU, because even CHRF, which is a metric that we didn't talk about here, but it works at the character level, and for some languages is much better than BLEU, for example, and it's still lexical, overlap-based, and super fast. Quality estimation allows for estimating the quality of translation hypothesis without the need of reference. When you need to make a decision about should I use this translation or it needs to be worked, still be worked by someone. And OpenQE and Comet QE present state-of-the-art performance according to public benchmarks, so they are as good as they can be compared to what's out there. And another thing is just reinforcing a bit what we've been talking about, that in our specific translation pipeline, automated translation evaluation is essential, right? So we need that for scaling the translation process and maintaining translation quality at the same time, and at the same time driving down cost. So because we can decide whether we should post-edit everything in a job or just part of it in a reliable way. And without automated translation evaluation, you cannot do that. And still, there are challenges, right? We have challenges with, even though we have Cometinho, We have challenges still with speed because, you know, we get a smaller model, but it loses a bit. So we need to continue working on that. And sensitive to specific types of translation errors. So these are, in my opinion, this is always going to be a work in progress, but we need to do better in these very sensitive terms and very sensitive parts of the translation. Thank you. Sorry for rushing.
Okay, let's take some questions. We have one last part of putting it all together into a picture of framework and how everything is together. But if there are any questions, even here online.
Can I see? Nothing online? Okay, thank you. Okay.
Can I ask a question? Okay. Hello, this is Machi from Translating. I was wondering, would you mind telling the percentage of translations that go directly to the client without any post-edition? So for example, when the quality estimation tells you that the quality is there, I was just wondering if it's like 80% or 90% that are post-edited, or if it's like, I don't know, 50-50?
So this depends on the language pair, and it depends on the customer, and we can actually adjust this. So I don't know specific numbers that we use for each client. I don't know if you.
So the important message is that depending on the quality level that is expected, because it can be content type specific, we can then basically tune how much, exactly where that threshold is going to be, and what is going to be sent with or without sending it to post editing. So it basically allows us the flexibility to actually be, rather than sending 100% of the documents to post editing or raw MT without any post editing, we can actually customize it depending on what the final quality, and that threshold can be basically then tuned based on a quality level, depending on the performance of the MT in particular. So for some language pairs and content types where MT is very good, it might end up being 90%. For other language pairs, it might be only 20%, right?
Okay, yeah, I guess it makes sense because the task at hand is has a lot of depth because we're talking about different client language pairs and domains. Yeah,
right.
So it's it's about
very
in this
nuanced.
case customization. Yeah,
exactly. Okay. All right. Okay, Silva, you're welcome to unmute and ask your question.
Okay, thank you. So this is for Jose. So in this conference, I've seen many people using things like number of words in a sentence, how many long words, how many nouns, and things like that, which kind of looks like the features at the beginning of the QE when you use these things to estimate. And people are calling that source complexity. In many of these presentations, you saw this, let's estimate how the source complexity. To me, it looked like they were using features, right? Oh, this source has that many words. And one specific, so my question is that true? Are features making a comeback? So, and the other specific things that I saw a sentence that had many chemical compounds, for example. So if you can't send through the mail this, 7 or 8 chemical compounds, they will be rare words, right? They will be rare words in any content, in any model. So can you identify that and say, oh, this sentence, I'm going to do something different. I'm not going to use it to calculate the total or something like that. So are we able to get anything from looking at the source, what the source looks like? Thank you.
Okay, the first question first. So yeah, if you're looking at source complexity, this was a class of features that we used to use in the past when in feature-based quality estimation, and it's basically looking at the number of punctuation that you have in the source sentence, because this probably will tell you that the sentence is composed by several clauses or things like that, or the LM score, in the past, or the number of nouns, or like you say, this is source complexity. They are not really needed anymore if you're using a pre-trained language model, but you can always try to embed this to the representation of each sentence when you give the input to the pre-trained language model. I never done that, but this might be a way maybe to make the system focus on something that you want, but it's a bit of a research question if this is needed or not. I would say no. As to the second question, you saw compounds, and you think that these fine-tuned metrics are going to fail on that, on recognizing translations with that? Is that what you meant?
Yes, they are rare words. So this is an example of rare words. I'm sure they're not in the model very often.
Yeah, well, it depends a bit if they are composed by characters that were part of the languages that the pre-trained model was built on. So for example, if these chemical formulas use CH capital and then two, or it's going to work because these models are prepared to deal with out of vocabulary words. They go back to the character level basically. But if, for example, the CH is with the two that is under score, like, I don't know, or the exponential, for example, probably, or this might not have been seen when people were building the pre-trained language model, and because of this might be on OOV. So you're right, but it depends a lot on how these pre-trained language models were built. And actually, you can do something to include this specific vocabulary to the model that you have during fine-tuning. So we have some work at Unbabel that we are doing that currently for MT, and it works pretty well. We can talk about this offline if you want.
Okay. All right. So let's just jump to the last presentation. Okay, so last half hour, I know it's the end of the day. I really appreciate all of you that are stuck with us, and hopefully it's been worthwhile for you guys. So I'm going to try and just wrap up here by kind of giving you a high-level perspective about the ecosystem that we've built around all of these technologies and methodologies that we've been described, and how they actually contribute and come together and into what I really believe is an ecosystem that continuously improves and not just improves our MT and translation results, but actually improves our technologies that we've described here to become more and more accurate over time. All right. We'll quickly do just a kind of a reminder of basically what we've seen here, and try to situate this in a perspective of an entire framework with different parts that fit together. And then I'll try and put the spotlight and highlight particularly the benefits of putting together an ecosystem like that, and then conclude by demonstrating, how that ecosystem actually kind of comes together and all of its components. Kind of the foundation of this entire ecosystem that we've seen is actually the entire framework and process that we actually do at a fairly significant scale at Unbabel of doing human annotation and doing post-edition with frameworks that are well defined. So you've seen MQM, So in addition to all of our post-editing work that we do on content on behalf of our customers for delivering them translations at the quality that we expect to deliver to them, we have the human annotation process and the community of human annotators that does MQM annotation. And this builds a significant database of MQM annotated, humanly annotated translations that actually is the real core of the training data that we then use to train our automated metrics, specifically COMET and our quality estimation technologies. So all of this human process that we do collects quality information using frameworks like MQM, and this is our most valuable source of proprietary data and feedback. It is limited and slow, but it is actually the most valuable thing to then leverage in our automated quality technology. Automated metrics, so we then train methods to evaluate our MT systems and know quickly which models should be deployed. We have automated retraining processes for all of our MT systems that are adapted and fine-tuned specifically for our customers. And those automated training run on an ongoing basis, often as frequently as every few days or once a week, and automated decisions based on automatic metrics are then reliably done in order to decide without human involvement whether retrained models should be deployed or not deployed. And then quality estimation, you've seen where that fits in our pipeline as well. So we can train AI models to predict MQM on the fly, and we can then use them to make intelligent choices about what to send to customers with or without the need to send specific translation of a document or a piece of content to editors. And even if it's sent to editors, we can actually then highlight what they need to focus on. So we have the best methods also involving training on human annotation. And finally, customer expectations and complaints. So our quality information helps us determine how we communicate quality to our customers. You've seen the customer utility analysis dashboards that we generate based on the human annotation that we do on an ongoing basis. And we also have customer complaints that then highlight specific errors, which we can then correlate back to both the things that we see when we train our models, and also things that are reflected in our customer utility analysis analyses. So the main benefit basically of putting all of this into an entire framework and feedback system is that we can actually use all of these components to continuously drive improvement over time. So over time, all of this information is flowing between the components can help us grow and improve the quality of all of these components in this entire ecosystem. So we can use the accumulating human annotations in the form of MQM in order to retrain and improve our COMET and QE models. We can use QE to double check the content that's produced by human editors. We can check the correlation of annotations with QE in order to identify anomalies and cases where our annotators need to be retrained or evaluated. And we can use customer complaint to isolate errors in our processes and, for example, detect things that COMET or QE are not sufficiently sensitive enough for, and then continue to improve those metrics. Okay, so that kind of comes together in what we call the Unbabel quality ecosystem, and basically the vision here is that I want to instill on you, which I think is somewhat unique to what we do, is that what we strongly believe in is that our ability to accurately identify, quantify, and monitor translation quality throughout the entire translation journey, both when we train machine translation models and then in production as translations come and are processed by MT and decisions are made about whether to send them to human editors and to check the work of those human editors, the ability to actually measure, monitor, and then make decisions based on translation quality throughout that entire translation journey can fundamentally drive a translation ecosystem that has virtuous feedback loops that continues to improve over time. Some examples of things that you've seen here today and things that we're working on and are not fully in production, but I want to really point out. So we can really leverage translation quality technology throughout the entire translation ecosystem and do very sophisticated things that are typically somewhat unique to us and I think are more difficult for other providers to do. So one that we've already mentioned is QE routing. So MT generated translations that are identified to contain translation errors are routed for correction to human edits, or alternatively, ones that are identified to be very good in quality and do not and meet our quality requirements do not have to be sent for human editing and can be skipped and delivered without human editing to our customers. We can use our QE technology to evaluate the work of our editors. So the human editors that do post-editing, we can use increasingly now our QE technology to assess the work that those editors are doing, to make sure that they are actually doing the editing that we're expecting them to do, and to curate a community of highly performing translation editors, and also use them to test and verify the work of our annotators. We can use the QE models to automate the work of selecting and doing filtering on training data for our very specific machine translation models that are trained for our customers, ensuring that the MT models are trained and retrained on translation data of the highest quality by leveraging, again, our automated QE technology. Of course, you've seen that we use our automated MT model evaluation, COMET, as our MT our primary metric for evaluating our MT models. So when they're trained and retrained, particularly after retraining, we can do a COMET plus MT telescope is used to actually decide largely automatically whether a new model should be deployed. And we're now working on several additional use cases for particularly our QE technology. So we're trying to automate and improve the productivity and also the consistency of our human annotators that are doing the MQM human annotation by pre-annotating those errors using error detection and highlighting using our QE technology. So you saw the annotation tool. In the annotation tool, we will already pre-annotate and highlight to the annotators where we believe the translation errors are, and to capture their attention to that's where they should focus their attention and effort. And fundamentally, the accumulating annotated data that all of these processes then derive serves us to further improve the models that are used to evaluate our translation models and to detect translation errors. So as the database for all of this, which is proprietary data that we keep at Unbabel, I'm open about this. This is not data that we typically release open source. This is our most valuable data that helps us to continuously improve the performance of both our automated technology and then of our machine translation models and what we deliver to our customers. So kind of in a picture, it kind of looks like this. You actually have basically this flywheel that is a lot of companies like to use, but I think is really appropriate in this case, where kind of the starting point is sort of the top left here with our human annotation and human evaluation processes that are based on MQM. That drives us then to actually quantify and detect business critical errors on behalf of our customers. That data is used to train our automated metrics, COMET, and our quality estimation measures. It powers then the analysis that's done by MT Telescope and the dashboards that we show to both to our internal LangOps operators as well as customers in the form of customer utility analysis. And this is a self-reinforcing type of flywheel. Okay, I have some recap slides here just to remind you of things that we've already seen. On the human side, I think the focus that we tried to convince you guys that we see a lot of value in doing detailed human error annotation driven in a principled way by a framework such as MQM. I think we've seen that there's been some significant adoption, particularly over the last couple of years, by many of the machine translation providers and to some extent some of the LSPs about really leveraging MQM as a primary framework for doing human annotation and measurement of translation quality, both for machine translation and for human translation or post-edited translations. So we've seen this is again the annotation tool. Just to kind of like remind you of the main points here. Human evaluation in the form of MQM, a primary method of translation quality evaluation used to evaluate both machine translation and post-edited machine translation or human translation. It's a primary data source for training our evaluation metrics and QE. It feeds our customer utility analysis and what we present then in terms of quality results to our customers. And it's used in automatic evaluation of editors and now also of annotators. Human post-edition, we didn't talk much about our methodology about human post-edition, but in terms of the data that it generates, first of all, it ensures, of course, high-quality translation output. It's the primary source of training data for our QE models. The MQM data is an additional source that actually helps our QE models become way more accurate and specific. And it's used to evaluate and establish annotator agreement, and it feeds into our translation memories, of course. Customer utility analysis that we've seen here. It's basically the dashboard of quality that we end up basically using to monitor on an ongoing basis quality performance on behalf of our customers and generating dashboards and customer reports for our customers. And the main thing that this allows you to do is to segment, again, different types of content that have different quality requirements and actually see that you're meeting those quality requirements for that type of content. Not every translation content type has to be perfect in translation quality. And we have the ability then to actually make decisions about putting together workflows and pipelines that are targeted to meet the expected level of quality and monitor and see through these dashboards whether in fact we're delivering that level of quality that is expected. We've seen these, again, quality targets and how to use customer utility analysis to see if we're meeting quality targets. So again, summarizing, it's customer utility analysis is basically the methodology we use to bucket MQM scores at the level of projects or documents that are delivered to customers in meaningful ways, and allows us to give us a summary of translation quality that is useful for our customers. Business critical errors. We've seen basically that there are mechanisms to ensure that translations that we deliver are fit for purpose, and mechanisms for detecting and quantifying critical errors that are specific to use cases and specific to important things for our customers, while keeping linguistic quality basically as a uniform thing that we can measure and compare equally across all of the use cases and across all our customers. Okay, I'm just gonna skip forward here. Okay. Automated metrics, we've seen both the strengths and the weaknesses. We're just highlighting here again some of the weaknesses. Again, this was already covered, basically some of the, just reminding you guys of how we're addressing some of the weaknesses that were identified. So again, just to recap, the main takeaways about using state-of-the-art metrics like COMET, fast and accurate quality assessment fed by our MQM annotation and our post-edition. Even though you've seen basically the publicly available versions of Comet, the default one is a direct assessment version of Comet that's trained on publicly available data. I will tell you that internally we primarily focus on using an MQM, specifically a fine-tuned version of Comet that generates predictions of MQM scores and aligns with our internal usage of MQM scores throughout our entire ecosystem. Okay. Quality estimation, you've seen basically how quality estimation is used. And the main point that I think is worth pointing out is that our quality estimation systems are significantly improved in their accuracy over the past year or so. We're looking forward, the results actually of the shared task this year really highlighted that. And I think what's particularly exciting is that in addition to just improving levels of agreement with quality estimation scores and human judgments like MQM, we see significant improvements in the ability to actually detect actual errors at the word level, the way that Jose showed you, and the way that I showed in the demo that I showed in our demo session a couple of days ago, for those of you that were there. And quality estimation is way more applicable than Comet or than metrics, because it allows you to really monitor the quality of translations at translation time throughout the pipeline and make decisions based on that. So the ability to detect actual translation errors, both from MT and also after post-editing, or basically from humans, is extremely powerful and is getting much more accurate with recent developments. Okay, so basically, again, the takeaways here, we really believe in this concept of QE everywhere, pervasive throughout the translation journey. It's used to assess whether or not we can skip post-edition. It's trained both on MQM annotations and post-editions, and we have a potential to use it potentially even as a MT evaluation metric, and many other uses that I've tried to highlight here earlier. Okay, a little bit about future work. One of the areas we're really looking into is assistive tooling. Can we leverage this ecosystem to increase the productivity and effectiveness of our human community, both our post-editors and our MQM annotators? And we're making some really nice gains there. And then human so I basically said not just our post-editors, but also improving the productivity and consistency of our human evaluation and annotators. Okay, so finally, just to kind of wrap this up, I want to put back the slide that I presented also at our demo session a couple of days ago. I think it's actually quite important to have a perspective about asking the right questions. Everybody in this community, as I said at the very beginning, is fundamentally looking at sophisticated solutions for combining machine translation that's getting better and better with the need for human involvement to deliver the quality that is still required for most enterprise use cases. And I think in that context, it's really important to ask the right questions, and not so much to focus on questions like which MT system is better, kind of out of context. Is it Google? Is it DeepL? Is it Unbabel? There is no correct answer to that question, and that question is actually limited in value, because all of those systems are good in specific use cases and instances, but in isolation, running a test, an offline test about which is better on a subset of content that you isolate is not usually a good predictive or a sufficiently predictive measure for how accurate or useful any specific translation is at the time that you're actually generating it on a translation platform, whether it be Google, Unbabel, or anybody else. Or does it tell you whether it needs to be corrected or what needs to be corrected? But the technology that we've shown you here, particularly QE, are now increasingly better and capable of doing that. And similarly, asking questions like whether Google has or Microsoft have reached MT human has their MT reached human parity is not a really productive or useful or consequential question to ask, because even human translators make mistakes all the time. And if you don't have the ability to detect whether or not they've made mistakes and to highlight and make decisions based on those mistakes, then it's not really consequential to say whether an MT system is at their level of quality or not. So this is a bit maybe, a strong statement, but I think we're still in a world in which the majority of LSPs, practically everyone that uses these days machine translation will tell you that they use MT and they use humans and they deliver the best quality. And what they typically mean is that they run through the best MT that they can. Sometimes it's generic, sometimes it's adapted, and then they send 100% of the content to human editing. Why? Because they don't really have the ability to decide whether it needs human editing or not, or what should be edited. And I think one of our points, that we're trying to actually make a strong argument about is our unique technology and the ecosystem that I presented to you here today allows us to actually have the best technology to measure, monitor translation quality everywhere on the platform for both machine translation and for the human-generated translations that our post editors do, and then to intelligently act on that information and create basically segmented workflows that optimize the combination of machine translation and human edition in a more nuanced and creative ways than most others can do, I think, out there. All right. So again, just that ecosystem coming together. And basically that's it. I know we're out of time. If there are any final questions, you're welcome to stick around and ask us. I think some people are eager to get going. I know it's late. So thank you everybody, both here on premise and online, that have come and participated. We hope that you got a lot out of our tutorial, and you're welcome to reach out to us anytime with follow-up questions. Thank you.